Hello. There is no audio.
I can hear you.
Okay, very good. I can't hear anything from the venue.
All right. Good afternoon, everyone. Thank you for coming to the Division C days, and I hope that the room will fill up over the course of the next hour and a half. My name is Richard de Grijs. I am the president of Division C until the end of next week, and then I can rest on my laurels, and Edward will have the heavy duty to take over. We have a fantastic program for you today and on Monday, and it was very difficult to put together. We had after the compulsory components like commission highlights, etc., we had 5 open slots, but we had received about 170 abstracts. So you can imagine it was not easy. We did a triage system, and I think the program is great, but if you did not get a talk, but only a post, no, not only, but a poster, that doesn't reflect on the quality of your abstract, okay? I wanted to make that clear. We are starting today with an online speaker. I didn't realize our speaker was online, but we have an online speaker for the first brief session. And we thought it would be appropriate to have a eulogy of someone who has been very active in the division and unfortunately passed away recently. This is Paolo Bretones. His good friend and close collaborator, Urban Eriksson, is going to lead us in remembering Paolo. Urban, please take it away.
Thank you. Can you hear me? I hope so.
Yes.
Very good, very good. Yes, I've been asked to say a few words about our dear friend Paolo Bretones, and he was really a passionate astronomy educator and researcher. And he was also the former president of the IAU Commission C1 for Astronomy Education and Research. And I met Paolo for the first time in Vienna at the International Astronomical Union General Assembly there in 2018. And he immediately started to talk to me since he had read my work and found it interesting. And this was the beginning of a very fruitful collaboration that led us to organize 2 international conferences and a journal. And beside all this, Paolo also encouraged me over the years to engage in the IAU and the Working Group for Astronomy Education, Research and Practice, a work that over the years has led to so many contacts and interesting discussions with colleagues around the world. And it was with great sadness that I, during the end of 2022, understood that Paolo was unwell. And by the beginning of 2023, our otherwise weekly meeting ceased. Paolo could not continue the fantastic work he had done and passed away during summer 2023. Very sad indeed. But let us remember him for some of his achievements and personality, because many of us who knew Paolo also remember him for this, because he always brought his camera with him and took so many photos and videos of everything that he could find and do. I wish I had access to all those fantastic photos. That would be an incredible thing. This photo here was taken in Vienna, and maybe you can see that we are visiting Dr. Freud. And he found it so interesting and had so much fun when we did that visit in that museum. So, but he also did a lot of other stuff, of course. He was so much involved and engaged in astronomy education and research. He had such a big passion for all of this. And this engagement led him to so many activities around the world. For instance, I want to highlight this astronomy in school, which is continued very well by Tomita. And well, it has really exploded. He was also the astronomer in Brazil media and often had an opportunity to talk about astronomy to the community. And he really liked this type of conversations and interactions. And also his engagement in the IAU is admiring. When you see the list here of his past affiliations with the IAU, one can only be very impressed. He really liked astronomy education and research as well. He also started a journal. Already in 2004, he started and was editor for this Latin America Journal of Astronomy Education, RELAA, who publishes mostly articles written in Portuguese and Spanish, but there is also some English articles here. And what one can say is that Paulo, he really liked methodology. Over the years, when we have had our discussions, this was something that was at the core of Paulo's thinking when it came to astronomy education research. One needs to be very careful with the methodology that you present in your manuscripts and articles. For the RELAA journal, there is now 37 issues published. Very impressive indeed. But we also started the Astronomy Education Journal, and it was launched at the conference in Garching in 2009, where Paulo and I saw a great need for astronomy educators and researchers to publish their work. At the time, and now as well, there is no other journal that meets these needs. Paulo was pushing me forward as new editor together with him, and I learned so much from him. He had so much experience, and he was eager to share it. Today, the International Astronomical Union has published many really good articles, and we have a steady increase of flow of manuscripts. The journal is now well known, and colleagues see this as an important vehicle to publish their work. And we need more reviewers here, so please sign up. This is something that also Paulo was so worried about. We need more reviewers. He always said that. We also started to organize the Astro Edu conferences. This was at the heart of Paulo. He wanted conferences where researchers and educators could meet and talk about astronomy education. So the first one was held in Garching in 2009. There was approximately 120 participants from all over the world. And the second one was planned for 2021. But then the pandemic happened, you know. So most activities were put to a hold. And the same thing happened with this conference. If there was something that Paulo did not like, then it was online conferences. So we decided we don't do a conference in 2021 because those conferences were supposed to happen every second year. So the third, which was the second conference, actually happened in Toronto in 2023. And to honor Paulo, we actually continued the work with this conference. We started in 2022, but when it became obvious that Paulo was ill, we had a discussion around should we or should we not continue the work with this conference. But we decided to do it to honor him, and I wish and I believe that he really wanted to be part of this. Unfortunately, he couldn't. So Paulo, he was such an inspiring force for me and for many others, probably many of you sitting in the audience as well. And I deeply miss our discussions, his dedication to astronomy education, but most of all, his humor. We laughed so much during all our conversation, and I'm quite sure that many of you can recognize this. He was a man who it was so easy for him to laugh, and he was always full of jokes and everything. So Paulo, I miss you deeply, and I will always remember you. Thank you for all I have learned from you and all the laughters and everything over the years. May you rest in peace among the stars. Thank you.
Thank you, Urban, for those heartfelt words. I can tell that the Astro EDU conference has become quite high profile, even with the executive committee. So there is quite some impact, quite positive, I think. So thanks for co-leading all of that with Paulo. Are there any questions, perhaps, at this point? If not, then I propose we move on to our second speaker. Thank you, Urban, for that nice eulogy. Our first science talk, if you like, is by Tomita Akahiko, who will talk about Astronomy Day in schools. And I'll give you a 5-minute warning. That is going forward. That is the pointer.
Forward, backward?
No, pointer.
Pointer. Okay. My time slot is 20 minutes.
It's okay.
Yes, it's very important to make my presentation within the time slot. Okay, so I'm Tomita from Japan, and my talk is one of the achievement initiated by Paulo Bretones. Okay, so Astronomy Day in schools, ADIS, as abbreviated, as a sub-working group within Division C, Commission C1, working group of astronomy education research and methods during this 3-year term has been able to move forward thanks to advice and encouragement of many people, including you. I would like to say thank you very much. So, okay. So first, let me explain what the ADIS is. It's a project to share astronomy education practices and materials worldwide. The ADIS features are quarterly online Zoom meeting focused on equinoxes and solstices. As for the goals of the ADIS, we now summarize them this way. To increase the interest of students and teachers in astronomy, to increase the international understanding, yes, we emphasize this very much, and to increase the confidence of teachers in classroom activity. So before going in detail, okay, so I'm giving a summary of evaluation and the challenges of the ADIS that I want to present today. So this is a schematic plot of the steps toward the goal. Based on the feedback from ADIS participants, I will explain later, we are at the 3rd to 4th out of 10 of the scale to the goal. The lack of sufficient interaction, so I hope we want to have many kind of interaction, but it is not so easy, especially between students, and the lack of accessibility of the materials shared within our participants were challenges pointed out by the participants. So now, so our evaluation is at that point. So before going in detail, so let me briefly explain how the ADIS started, but please forgive me for not introducing all the people related because the time slot is very short. So it was one of the originally IAU 100 programs, but before that, this was an idea of Paulo Bretones. So the idea was to support the teachers and to provide what was useful for the teachers. Paulo came up many new ideas, and one of the ideas was the Astronomy Day in schools. So as a teacher training faculty professor, I knew that many school teachers were interested in astronomy and sciences, but they are not so confident in teaching astronomy. Maybe you agree that. So helping teachers see how astronomy is connected to daily life and history and culture of our society is very effective. And maybe all of you here agree with this strategy. And Commission C1 President Bun Raksa was a strong supporter. Maybe he is here or he is online. And group of Iranian teachers. So Iranian teachers are very active. So who have been working for many years supporting students' autonomous activities, especially young women's students. Proposed an online meeting at a celebration of equinox and solstice. And the first Zoom meeting took place on the March equinox 2021. So since then, so there are many programs, 13 times so far. These are the flyers designed by Iranian colleagues. Please forgive me, the letter is very small. The ADIS sub-working group member under Commission C1 consists of 20 members from 12 countries and regions. Some of members are here today, so thank you very much again. And Paulo and I were the co-chairs, but unfortunately and sadly, Paulo passed away last year, and I continue to be the chair. Okay, so this is an example of the timeline of the program. So started at 10 a.m. Universal Time and lasted 2.5 to 3 hours for and reported reports from several countries. So the participation is not from a huge number of schools, so I hope so. But several schools from several countries. From east to west to Eurasian continent, especially. So many schools from Thailand introduced by NARIT, a National Astronomy Research Institute of Thailand, and a large number of schools from Romania every time. So the Romanian representative here, so thank you very much. Introduced by Anna Nagy and colleagues, the NIAC Romanian team. So it just so happens that there are a few countries where English is the native language. So we managed to communicate with each other in English. It is fun, and sometimes it is very difficult. Okay, so this is a summary of the statistics of the participants. Each time about 100 to 200 people are listed here who are involved in the preparation of the presentation, including teachers and students, and the certificates of participation were issued to all of them. Okay, this is an example of the certification. So please take a look at some of the practices and materials shared. So this is the practice of measuring latitude and longitude simultaneously in 3 significant digits from a Norman type sundial. It's very simple, but some simple calculations. So we can say, for example, 135 degree east and 34.6 degree north. So it is at my house, okay? So in 3 significant digits. So this is a practice from Japanese high school teacher, and this is from a Romanian teacher. And this is a practice in Puerto Rico and Chile, where latitude were measured simultaneously in both the northern and the southern hemisphere, and they feel the roundness of the Earth, not flat. Okay, the topic of the Astronomy Olympiad is next to my presentation. Maybe oh yes. So so speaking of the Astronomy Olympiad, so the Bulgarian teacher Nikola Karavasilev, maybe you know him. Okay, so he introduced the students and the mentor activities. Okay, this is an example. So archaeoastronomy is another major topic. The solstice and equinox were important points in the yearly cycle of the heavens, so which were necessary to know for agriculture, ritual, ceremony, and the daily life. So therefore, ancient structures, this is an example from Peru. This is an example from Iran. The ancient structures, buildings, and the road system were also the observatories. So this is what Commission C3 and C4 have been investigating. And also, this is an example from Hellenic Institute of Egyptology in Greece. Also made an introduction in ancient astronomy in Egypt. Okay, so this conference is held in Cape Town, so this is some relation to the African continent. This shows that the project of digitization of the ancient Egyptian astronomical texts, project DSEAT, led by Dr. Alicia Malavella of the Institute. This is also presented in the poster of this session. So the student club activities in Thailand, with advice and instruction from NARIT, Star Watching Party, building a mobile planetarium. Yes, it's very gorgeous mobile planetarium, and outreach activities in the community using these devices. Stories of trial and error to make a spectrograph and a radio telescope by high school students. and survey of light pollution using cell phone camera to photograph the starry sky, proposed by the teachers in Iran, and the model exhibition by the Romanian students. So observation of the light pollution depends on the weather conditions. So we can discuss the weather by the weather map. So we can exchange and read the weather map globally. So not only the starry sky, but we can use this kind of material. So up above all things is astronomy. Okay. Okay, so this is a photo by Iranian teacher showing how different day changed the location of the sunset. Yes, this beautiful painting works inspired by the autumnal equinox was created by a Romanian 14-year-old students. So it's very impressive and very artistic. So, and Romanian students also introduced us various aspects of the relationship between astronomy and our daily life, including dancing, singing, festival room decorations, and clothes decorations, and folklore. Yes, these are examples of teachers and students from various countries. Maybe you know some of them via Zoom and not face-to-face, but it's still fun and wonderful. So finally, here are some photos of activities by Iranian students. Continuous large-scale autonomous activities, and both male and female students, astronomy observations and analysis, and safe and enjoyable organization of astronomy camps. So yes, education is a common practice of humanity throughout this planet, regardless of gender, age, and national borders. So this is a poster. There is a poster from the Iranian colleagues, some posters, Mahdi Rokni and Hassan Bakbani in this session also. Yes, this is very impressive because, for example, in an East Asian country, including Japan, we know little about other countries' education situation through limited information sources. But through ADIS, teachers and students directly share so their activities. So we now know that so teachers and students are very hard worker in every country. So it's very useful and what we want to share with many countries. So now that how did the participants evaluate the program? Okay, so this is the main point of my presentation. So on a separate day from the separate date, okay, is it okay? We asked approximately 3 minutes, okay. Sorry, so 190 recent ADIS participants to respond to the survey. Okay, 3 minutes. Okay, I will put my PDF file in the Slack later, and you can retract my slide later. Okay, so I will flash. Okay, so I asked 3 questions. First question is, what was your experience participating in the ADIS that was find beneficial? The question 2. What are practices and materials that you want to refer to and resources that you are interested in at ADIS? So, okay, the question 3, what do you feel is currently lacking? What do you think is needed to overcome it? It's very important question. So question 1 and 3 to see how the ADIS goal was achieved, and question 3 is to see how ADIS goal was not accomplished yet. Okay, so maybe 1 or 2 minutes. Okay, so I will jump to, okay, so I would jump to, okay, so this is the result of the feedback. Sorry, but please see my slides later. So the students' interest in astronomy and international understanding have improved both perceived by the students themselves and as observed by teachers. and school teachers interested in astronomy has improved at ADS, has contributed to confidence improvement in their classroom activities. So yes, this is the accomplished that we have achieved so far, but both teachers and students pointed out similar challenges. So they kindly pointed out many challenges. So the first one is lack of communication, especially between students and schools. So now the program has the format of the presentation. So there are many presentations, many useful information, many interesting materials and practices, but usually we packed the many presentation, but the lack of communication. So teachers and students are complaining about the lack of communication. So the second one is material introduced to each other remain unreferenced effectively. So we have the the third one is language barrier. It's a very serious problem. The fourth one is the many schools for many continents cannot participate. So so the possible solution. Two more slides. So prepare 3 minutes. 3 minutes is too long, some say, but for example, the short pre-recorded video speaking either in their native language or in English with English subtitles. So prepare the video in advance and introduce the video in advance if possible. And afterwards, use the Zoom breakout room, for example, to have the casual communication, and create a site together with the participants, not only by me, where all participants can put and organize their materials before and after the program. The site will have both a peer inside site for school-to-school communication and a public site, which will be open to many people around the world. Okay, so these 3-year terms, so we managed to maintain the Astronomy Day in School program for 13 times. The next 3-year term, so we will have make the ADIS to ADIS 2.0 with the new method, and yes, we want to go up higher to achieve the goal, and I appreciate your advice and encouragement and suggestions in the next new 3-year term. So thank you very much, and please refer to my slides later.
Thank you very much, Akihiko-san. Any questions?
Hi, Tomita. You had said that about the GNOMON. GNOMON, you can measure latitude and longitude very accurately. Yeah, what was the size of that GNOMON? Because
size of
GNOMON is how much?
Money?
The size, height of the GNOMON for the latitude, longitude.
Latitude?
Yeah, latitude, longitude, you measured with a GNOMON stick. Yeah.
The size of the GNOMON?
Yeah.
15 to 20. Okay, so like this.
But then you will not get very high accuracy measurement for the latitude, longitude.
Yes, it's possible. It's possible. So shown by the high school teacher, it's possible. So please look at the material in ADS. So it's possible in 3 significant digits.
One more question?
Thank you, Tomita. This is a fantastic program. One of the problems that we had implementing it in the UK is that space doesn't occur in the curriculum. Teachers plan to do space at inconvenient times, and so they don't fall at the solstice or the equinox, and which is the the 2 dates that you picked for that. And so I wondered if you'd considered having the astronomy day on different dates, or whether the 2 dates were so astronomically significant that that was really the main impetus for the program.
Okay, yes. So we are now thinking about many kind of possibility having another day, but so far the equinox and solstice are very popular among the teachers and students who come to frequently. Okay, so yes, we consider another options, but so far we have to managed and arranged the materials so far we shared about the equinox and the solstice.
All right, let's thank our speaker again. Thank you very much, Tomita. We've asked representatives of all 4 commissions of Division C to provide us with highlights, not overviews of everything they've done in the last 3 years, but highlights of the real things that you as the audience might find really interesting. Our first highlight speaker is Annika Zulle, who will be representing Commission C1. And I should mention we have a new Commission C5, which will also be introduced today.
Thanks, Richard. Sorry. So I'm going to talk about astronomy competitions as a way of motivating students. This is not exactly what Commission C1 has been doing so far, but this is something which we would like Commission C1 to consider. So we are all astronomy communicators. We have been attracting students by various ways. We do talks in schools or talk in our institutes. We organize open days. We do events in public space, like for example, this is a pointer. Yeah, this is a point. This is like going to a public space and organizing telescopes. Yeah, what happened? Where is that? Okay. Anyway, yeah. So or do star parties, or we can do. We have been doing science communication by writing articles in magazines or newspapers or blogs, videos, reels on Instagram, or do student workshops, teacher workshops. All of us have done all of these, and yes, they are successful in their own ways. But all these approaches have limitations. What are the limitations? First, we are preaching to the choir. In a sense, when we do organize a talk on astronomy, only people who are interested in astronomy will show up for your talk. Same is true for open days and so on. So we are not going beyond the people who are already interested in astronomy. Then second problem always is that science communication personnel are too few to serve the whole population. And so we can do only limited number of events. Also, many of our institutes are located in big cities or close to big cities. So if we can always go to the schools in that city or around the city, but we really don't go to schools much beyond that. And the e-materials, we can produce videos, put on YouTube, but there are already too many videos on YouTube. So you can't really, the students don't know which one to look at. For them, everything is same. So why competitions can be a slightly better route? First, you don't need to have personal presence in every location. You can design a question paper, send it to each school in a very remote area as well, and ask teachers to conduct that. So you can reach more people. We can cast wider net beyond the people who are already interested in astronomy, because some people would like to participate in the competitions just for the prizes. If you have not already come to the India booth in the exhibition hall, please come and see. When we say you will get prize by throwing a ball in a box, many more people come and try. Then some other people have skills which are relevant to that particular competition, like problem solving, or I'll give other examples as well. And hence the competitions can be managed by just fewer number of science communication personnel. Like doing the competition in different places, you can just take help of teachers and then bring all the entries together, and few people sitting in one place can evaluate those. We have discussed this previously in various IAU forums, and other people have expressed reservations about these. People have said that we need to promote collaboration instead of competition. But we always argue that collaborations can also be promoted within the competitive structure. It doesn't have to be one person getting prize, doesn't mean the other person doesn't get prize. You can have different kinds of prizes for different people so that everybody feels like a winner. Some people argue that competitions only serve students with high STEM aptitude. But competitions can invoke skills beyond STEM, and we need some. It is not just about STEM aptitudes. I will show examples. But secondly, if we are looking to nurture next generation of professional astronomers, we do need some efforts to target people with high STEM aptitudes. It is not just about everybody getting interested in astronomy. We need a few skilled people as well. Some people say that astronomy takes a backseat in a competition, but that depends on how the competition is designed. You can design competitions in a way that astronomy comes to the forefront. So I'll give some examples of different kinds of competitions, what can be done with astronomy. You can have competitions which are like involve astronomy and arts, like astronomy themed drawings or reels or costumes or astronomy themed brand designs. I will refer you to the talk by Fabio Miro in third IAU workshop. The proceedings are available on OE page. Then you can also have competitions like astronomy-based stories or poetry. There is a poster by William Waller in the poster area. You can look at that. You can have astronomy-themed plays. Then other way can be astronomy as a hands-on collaboration activity. There is a hands-on part and there's a collaboration part. So, for example, Croatia has been organizing competition of astronomy projects for several years. Again, this is a third IAU workshop. There's a talk by Daniela Takash. Those proceedings are also available. Or, for example, NASA has been organizing Mars Habitat competition, which is also of similar type. Then the traditional astronomy competitions, which are like Olympiads, which focus on STEM talent nurture. They aim to enhance the problem-solving skills of students. They give exposure to modern astrophysics topics. For example, in last few international Olympiads on astronomy astrophysics, topics like gravitational waves, microlensing, exomoons, co-orbital satellites, all these things were covered. And there are these few talented people who have very good STEM aptitudes. They have many options. It is not just astronomy. They can get interested in laser physics. They can get interested in quantum computing, many things. So the competitions at school stage make a case for astronomy over other subjects. So people can really get interest in astronomy, and if they get flavor of what actual modern astrophysics is. So that is another reason why we should have these competitions at school level. As I said earlier, we can reach much larger groups, much larger numbers as compared to our typical workshops, what we can manage. So for example, national Olympiads can actually reach more than 10,000 students in multiple countries: India, China, Brazil, Czech Republic. Several countries have 10,000 plus student participation each year. In Brazil, for example, the number was close to 900,000 just before pandemic. We have also seen examples where astronomy Olympiads can get initiated because of that inherent appeal of prizes and things like that, without support of professional astronomers as well. So countries which don't have professional astronomers, for example, Pakistan has just a couple of professional astronomers. Bangladesh has only one. Nepal presently has none. Singapore and UAE also very few professional astronomers. Even they have started their astronomy Olympiad competitions. So these kind of examples also exist. So I have been talking about IOA. Just if people don't know what IOA is, it's a problem-solving competition for high schoolers. It started in 2007 with 20 countries. The 2024 edition in Brazil will involve 54 countries, which is due to start next week. From here, I'm directly going there. And it works on democratic principles like equal voting rights to all countries, and executive committee like IAU is elected every 5 years. And what we have seen from 2007 till now, several of the Olympiad participants have taken astronomy careers in different countries. There is increasing interest in astronomy in all participating countries, including the non-IAU member countries. And because of this IOA, there are several spin-off competitions which have been initiated. For example, Latin American Olympiad on Astronomy and Astrophysics. There is an IOA Junior now for students under 15 years of age. And there is a European summer workshop for astronomy and astrophysics, which are also based on the IOA format. So I'm going to summarize by just a couple of the remarks. One is, so astronomy competitions are increasingly popular and widespread. Just like other EPU activities, they serve a purpose, and IAU should embrace this idea and leverage its popularity. Before I stop, I'm going to put in 2 plugs for announcements. First is, since all of you are interested in education, our institute hosts an education conference every 2 years. Next one is going to be in January in Mumbai. I have some flyers here. So if you are interested, please take flyers from me. And second plug is, I spoke about Olympiads. The next Olympiad for 2025 is also going to be in Mumbai in next year in August. So I have some stickers with logo. If you want, you can take from me. Thank you.
Thank you very much. We have plenty of time for questions because that was a short one. Michael.
Thank you, very interesting talk. I just wanted to put one other idea where you can do gaming or interaction and competitions. If you have access to a planetarium, there's an increasing number of products coming out in planetarium manufacturers, which basically are competitions, but they're educational and they often make use of mobile phones in the dome. So a planetarium is another way of engaging in these kind of areas.
Mariana, question?
Thank you very much. It was a very nice talk. So for the Olympiads, out of more than 50 countries, we currently don't have any African countries that is actually participating. And I think South Africa is currently putting an effort in collaboration with the DSI to create a national team. But I think we should really discuss more about it and see a bit how to offer more support.
Definitely, we are always ready to help. I'm here till the entire division of GA. We can meet me anytime at the India booth, and we will discuss in detail.
Okay, great.
In the past, we had participation from Mali for a couple of years, but then they stopped. And we have received requests from Ghana in the past. South Africa has been trying for the last 2 years, as you know. So people have expressed interest, but it never led to a team.
Some questions on this side? Yes.
Thanks, Aniket. We know very well that STEM and astronomy suffers from a lack of identity, even among high-performing students. They feel there's not a place for them and they still don't feel good enough. I was wondering how you mitigate that for the losers of your competition, and if you're capturing any information on potential poor impact of that.
It's a very good question. So far, since Olympiads, organizing is being a voluntary effort, executive committee is just doing it as an additional responsibility. So we have not focused on that, but this is something definitely we would like to investigate. Not just focusing on the medal winners, but also people who did not get medals at the international or even at the national level. We will discuss probably together how we can develop a way to investigate that.
Anyone else? Yeah.
Thanks for the talk. Anyways, I have a question about the promotion of equity, not only in gender, but also about the social part, because, well, in the Brazilian Olympiad, there is a huge gap from the people who is part of the teams of the Brazilian Olympiad and the people who do the competition itself. So there is an activity just to promote it, to make this more equal, or at least in India, or not?
Yeah, so I can give you answer in the Indian context because I'm more familiar with that. I'm not familiar with national programs of each of them. So in India, we also face the same problem that many of the participants, or most of the participants, used to come from big cities and not from smaller places. Also, very few girls participate. So for girls, what we are going to do from this time is mandate a minimum quota in the first selection, because since there is a very large number of students participating, the first round is MCQ, and there are some studies in the past which show that time limited MCQ competitions boys who are trained to take these exams better than girls. But if you give more relaxed descriptive examinations, girls tend to do better. So in the first round, we are giving a minimum quota for the girls to overcome that barrier. Also, we conduct now teacher workshops very regularly to focus on teachers from smaller places where they can be trained to train their students to practice for Olympiads and things like that, so that we can't reach to every rural school, but we can certainly try to reach as many teachers as possible. So that is the way we are trying to solve this problem.
Thank you very much for your talk. It was really very good to see that other projects and communities also think of school competitions as a fantastic way to promote STEM vocations. One of the strengths that you perhaps missed in your talk of these activities is that once you prepare and once you design, prepare and organize a competition, you can reuse it several times. We at the European Solar Telescope project have organized one of these competitions about the sun, asking students to collaborate in small groups to produce something, an infographic explaining some topic about the sun. And we couldn't reach a huge number of schools, but the teachers who participated in that competition came to us later and gave us feedback saying that they wanted to repeat the experience. And everything is already prepared. So it's a very cheap and easy way to maintain a high level of activity. Once you do the big effort at the beginning, then you can reuse it. And I think this is an important strength.
Yes, this is very nice. I'll give you another story. Just last month, we had a competition organized for drawing of moon, because it was an International Moon Day on 28th July. And we partnered with some NGOs in Mumbai city to reach about 100 schools in Mumbai. And we had organized drawing competition for them. 7 days before the event, we got call from government of another state that can we include 5,000 schools from our state in that? I said, yes, everything is ready. Just same question, themes, say we just send it to you. You do it at your state, send your best entries to us. We will add them to our list. And we can do that.
A last question, perhaps?
Yeah, thank you for your talk. What would be interesting actually for us in Africa is to have like a platform to train students on these competitions. You have such platform that maybe could be shared with everyone?
Yeah, so what we have been doing in last few months, we just started, is take some basic astronomy concepts and make short YouTube videos, which we are putting on YouTube for free. So that can be a starting point. But beyond that, if you want to organize a teacher workshop, we are always ready to help. And by all means, we are not the only people having YouTube channels. There is a poster by Salman on the downstairs. I think it was for Division OE or Division C? OED. Okay, so he also has been making YouTube videos on astronomy. So there is a lot of good material available. So all we have to do at our level is find the best material, make a list, share it with students, and then based on that we can go to next step.
Well, that was a very good discussion. Thank you very much, everyone, and also let's thank our speaker again.
Please take from the
Yes, you know where to find Aniket in the India booth. Our next speaker will be presenting the highlights from Commission C2, Marike Baan. We'll talk about the CAP conferences.
Hello, everybody. Thanks for the opportunity to speak here. Let's see how this works. Okay, I think it's quite simple. Yes. Yeah. Okay. Cool. I'm giving this talk on behalf of the president of the OC, the organizing committee of C2, Communicating Astronomy with the Public, Oana Sandou, and Sylvie Vauclair, our incoming president. Both can't be here in person, but maybe they are online, I'm not sure. And I want to thank Kelly Blumenthal, the director of the OAO, for her last minute inputs yesterday. My name is Marieke Baan. I'm the Communication, Education and Public Engagement, thank you, lead at the Netherlands Research School for Astronomy, NOVA, and that is the collaboration of the 4 astronomy institutes in the Netherlands. This June, less than 2 months ago, the OAO and the organizing committee of C2 organized the 11th CAP conference in Toulouse in France. It was a fully hybrid conference, and the venue was the Cité de l'Espace, and that was really amazing. It was the 11th edition, as mentioned, and this conference series traces its roots back, I think, for over 2 decades. I'm looking to Richard. And of course has evolved to the needs of the community and also the changing health and safety landscape worldwide. And though the pandemic isolated us, it also brought something new, and that is that we were brought together by the rapid evolving online meeting possibilities. But before I move on to the activities and the role of the C2 and an overview of the latest 3 CAP conferences, I would like to emphasize that the CAP conference is really unique, a unique activity. It's not only the largest conference on astronomy, communication, education, and public engagement, and which brings together practitioners and scholars and astronomers doing communication and public engagement on the site. But I think it's also unique in science. I'm not aware of any other science field that is able to unite all those communication, education, and public engagement people. So, C2 is under Division C, Education, Outreach and Heritage. You probably know that all. We have 3 commission working groups. The working group CAP conferences, the talk will be about CAP conferences. The working group on communicating climate change through astronomy, and the intercommission working group astronomy in culture. C2 is a think-do tank that convenes the astronomy communication community and seeds initiatives to explore new ways to communicate astronomy with the public. It works, of course, in close collaboration with the IAU Office of Astronomy Outreach, with the Office for Education and the Office for Development. The primary target audiences of C2 are professional and amateur communicators of astronomy. And the primary mission is to advance the profession of astronomy communication and support the professionals. And while the OAO focuses primarily on engaging the public, C2 focuses primarily on engaging astronomy communicators. And we also, of course, support the overall IAU mission with this. Members contribute to the review of the CAP journal. It's a free journal, you probably know it all. There's a link if you want to look it up. Our members also support the AU Astronomers program of the OAO, and we have representatives in the OAO Advisory Board. A bit of history. The idea of Commission 55, now C2, was conceived in Washington, D.C. in 2003, sorry. After discussions between Ian Robson, Dennis Crabtree, and Lars Lindberg, the former IAU press officer. C2 was formally adopted, I think, or formed at the General Assembly in Prague in 2006. And a great synergy arose with the upcoming idea of the Year of Astronomy in 2009. And fun fact, the 2010 CAP conference also took place here in Cape Town, and it was for me personally the first one I ever attended. So the organizing committee is Joanna Sandou, our president, Sylvie Vauclair, the incoming president, Vinicius Oliveira is a secretary, and Richard Feenberg, past president and advisor. And the rest of the commission organizing committee is listed below. I want to remember Carolina Uitman, governor. She was on the organizing committee many years ago, and she joined again this past triennium. And you all know she passed away in 2022. But I want to thank her for all her contributions to our field of astronomy communication, education, and development through astronomy. So let's go now to the overview of the three latest CAP conferences. The first one is the 21 conference. Of course, the 2020 conference couldn't go through because of the COVID pandemic. And we had an all-time high number of registrations in 21, 1,346 from 87 countries. Many plenary talks, oral presentations, panel discussions, and 75 digital posters. There were 1,347 invitations sent. We used the Hopin virtual platform, and over 1,000 people registered, and in the end, the turnout was almost 1,000 people. And here you see the countries, 53 countries, I think. Oh no, that was the 28th one. Oh yeah, I wanted to compare the turnout of almost 1,000 to the 2018 conference in Japan. So we doubled, basically. This is a list of the countries. US and India are on top of the both of the lists. And then the CAP 22 conference in Sydney, Australia, was fully hybrid, and we learned from the 21 conference. I'm glad Richard de Grijs is here, who chaired the SOC by then, and because I didn't attend this one in person. So if there are the log, sorry. So if there are questions on this edition, you can ask them after this talk to Richard. There were 244 participants, 111 online, in person, and the rest online. And that's a bit less than the 2018 edition, of course. Some other numbers, we had 42 fee waivers by the IAU and a number of grants. And the talks and panel discussions and workshops are listed here as well. And this is a photo of all the in-person attendees in Sydney. This is a map of the country of residence of the attendees. Of course, many from Australia. And again, I see India and US, and I think Italy as one of the main countries of residence, yeah. This is an overview of the professions of the participants, also very interesting. Many public outreach and press and information officers, but also journalists, scientists, educators, curators, and planetarian professionals. Their educational backgrounds, mostly science, some only communications, media, journalism, but that's the real character of those CAP conferences. It's really a collaboration and a joint event for as well communicators, as practitioners, as astronomers. So that is a very nice group of people to be part of. The gender looks good. And then we go to the CAP 24 conference I told you about. It was organized in Toulouse, in France, in Cité de l'Espace, which was a really amazing venue. It was again fully hybrid, so as well in person as online participants could use a platform to look up the posters, to discuss, to attend and join all the talks, to give the talks, etc. And oh yeah, the topics of this conference this year is the 100th year of planetarium year. So there were many planetarium talks, and in the venue there was also a very nice IMAX theater, nice planetarium. So the planetarium was one of the biggest topics on this conference. 300 participants, not as much as the 2018 edition, but growing again. 204 in person, 95 online. 52 countries represented. This is a photo in the hall of the, I think, IMAX theater, where all 200 in person attendees are on. We had 12 keynotes and host talks, 13 plenary talks, many parallel talks, workshops, and 32 posters. And also for this conference, we had 5,000 euro grants from the IAU for travel and fee waivers. We also got a grant from a Japanese donor, and the LOC supported some fee waivers as well. Now, again, this is the venue. All attractions and things and planetariums were open to the participants. So we had a very good week, as well as because of the topic, but also because of this venue. And the next CAP will be held, I don't know, but it will be announced. It's the 2026 location and host will be announced before the end of this year. On the website, it says it will be announced this month, but it will be announced a bit later. This is the organizing committee of the CAP, and this is my last slide. And if you want to get involved in the C2 Commission, just contact one of us listed on the left. Thank you very much.
Thank you, Marika. Maybe I can start by giving some context about the Sydney meeting, which was meant to be CAP 2020, but because of COVID became CAP 2022. For 2020, we had expected 350 in-person participants. In the end, as you showed, it was 244, including online, because it was the first meeting after COVID. So that's why the numbers were a bit low.
Yeah.
And we were struggling with the hybrid model, which we had not anticipated before COVID. Yeah. Anyway, so there were lots of things, but in the end, it was
we learned a lot
of fun. Yeah. Any questions? Eric.
Thank you for this talk. In case of 2022, I think you showed the distribution of participants by professions. Could you go to this slide? I think CAP conferences could be very nice occasion for attraction of other scientists, as astronomy serves for as leader of interdisciplinary sciences. So do you have any information? What are these scientists? Are they astronomers or some representatives of other professions as well? There were mentioned scientists, just, but I believe they are not only astronomers.
No.
Yes. Do you have any information about it?
No, I don't have that information, but it might be, sorry, I don't have that information, but it might be available. And if you send me an email, I'll get back to you about that. Yeah.
There were some biologists and engineers for sure.
Yeah.
Yeah.
Yeah. In the Toulouse conference, there were also some scholars on science communication with no link to astronomy. So there are people from other sciences. Yeah.
Hi, Marika. I have a question on the hybrid model. So you've had a couple of conferences now that are fully hybrid or struggling to be fully hybrid. What's your experience? Is it attracting additional people that, for some reason couldn't make it in person to previous conferences? Or is it replacing people that would normally have come, but now have stayed home?
I don't have the exact numbers, but my feeling is that those are the latest group of people that normally would have come, but because they have children or can't travel or don't have enough budget for a conference, use the online possibilities.
So they're replacing more than the addition.
Yeah, but that's my gut feeling.
Okay.
So that's no science.
Okay.
I cannot say by all the people, but anyways, thanks for the talk. But at least for the Global South, that we can saw that there are no much people attending, but the fully hybrid sessions helped a lot to us because we have no funding to go to this kind of conferences.
Yeah.
So it really helps us to attend. Just like it was my first contact with communicating with public, like as a research field. So it really helps. So thanks for it. And thanks for the CAP conferences at all.
Yeah.
So it really
Yeah.
helps.
And it helps, and we're trying to raise funds for fee waivers, etc. So we think it's very important, indeed.
Any more comments or questions? If not, thank you very much, Marika. Our final speaker this session unfortunately couldn't make it in person because of visa reasons. He has provided a recording, but he is available online for questions afterwards. Can we have the recording, please? This is Miracle Chibutzor Marcel, Modern Astronomy Education and Outreach Endeavors in Africa.
Hello, my name is Miracle Chibuzo Marcel. I am the founder and the director of the largest citizen science community in Africa called the Pan-African Citizen Science E-Lab. So in this program, I'm going to be talking about our project and our achievement over the past 3 years. So in table of content, I will be introducing PasskiLab, our key project, and our results. So PasskiLab was founded in December 4th, 2020, and our aim is to promote hands-on activities in astronomy and space science through citizen science and soft astronomy research in Africa as a means of advancing space exploration and enhancing space education and outreach. So, and how we do that is by collaborating with entities in the global north and bringing those opportunities to Africa. And all our activities are online. All our activities are based online. So here is your official logo showing the map of Africa. Here you can see individuals with their computers or phones are analyzing and reducing space data. And that is exactly what we do. We also have a WhatsApp group where we interact within our community. So for the general requirement, all PasskiLab projects are suitable for all individuals, regardless of age, religion, country, sexual orientation, academic or professional affiliations, levels, etc. So to participate in our project, what you just need is to have a basic knowledge of computers, most especially Windows operating system, internet, and passion for space. Now, in our organization, we have different kinds of projects classified as primary project and secondary project. The primary projects are our main projects, and I'm going to be describing them one after the other. So the first of our primary project is the Pan-African Astro Research Campaign, and we collaborate with the International Astronomical Research Collaboration. We are their biggest partner in Africa. And in this project, we contribute in planetary defense through discovering new asteroids. We submit the report to the Minor Planet Center so that the orbit of these asteroids can be classified and continuous monitoring can be done in order to avoid events like this. We use the astrometrical software to analyze the images. Here you can see there are about 4 images taken at different time intervals. Here is the blinking windows. that blinks the images in order for you to see if an object is moving or not. That is how we detect asteroids. The data we use are gotten from the Penn stars located at the University of Hawaii and the Catalina Sky Survey located at the University of Arizona. Now, in this chart, there are more surveys around the world observing the sky, scanning the sky, and taking data, asteroid data. But these two are the most. They collect the most asteroid data. And now they have automated system in them that detect this asteroid, but not all of these, not all of these asteroids are detected. So they send the data, those data, to the International Astronomical Research Collaboration, so that we can use the manpower to discover this asteroid. So we are part of them, the Pan-African Asteroid Search Campaign, and here we engage different entities across Africa in the asteroid search campaign. So here is just one of our groups, the Amateur Astronomy Libya. So this is where the teams will download the data, analyze the data, submit it through here. So this is just the demonstration. So for the tools, to participate in the asteroid search, our participants would need Windows operating system, internet, and Astrometrica. Astrometrica is a free software. Now, in training, we have recorded videos in English, French, and Arabic. And here is just one example of one of my recordings in English. We also have Arabic and French. We have some of our members volunteer and develop those videos in other languages too. We also conduct online training via Zoom. So far, we have discovered 32 asteroids, and those asteroids were discovered by about 60 of our citizen scientists. However, we still have hundreds of preliminary discoveries that are yet to be confirmed. So here is the academic calendar for the new academic year. We started this August. It runs every month till May. That is how we conduct it every year. So here is our second project, Exoplanet and Photometry, and we collaborate with NASA Exoplanet Watch. So in this research, we contribute data. We contribute data in order to refine the mid-transit period of already discovered exoplanets in order for the future missions like the James Webb Space Telescope to study them again and in details in order to detect if there is life or no life in them. But the reason why we are doing this is because when these exoplanets were discovered by the Kepler and the TESS missions, their periods were not accurate. So we are actually redefining their mid-transit time in order to improve their period. So we reduce the data with the exotic software to produce this light curve. And after that, we submit the report to the American Association of Variable Star Observers. To participate in this project, we have 3 sources of data. Through the Exoplanet Watch website, you can request data directly from NASA. They would give you data if you submit your email there. We also have access to the Micro Observatory. There you can schedule your own missions. You can observe stars, okay, using the Micro Observatory. So this is the process of scheduling, and after requesting it, the Micro Observatory is going to turn around to focus on that spot. We also use the Los Cumbres Observatory for observation. We are part of the Global Sky Partners of the Los Cumbres Observatory. We have about 100 hours of observation time for our research and other endeavors also. So the tools for this research: any operating system, internet, Gmail. Gmail, not email, because This exotic program is a Python program, and it is mounted on Google Colab. So to be able to have access to it, you need a Gmail, and all the software is online. For the training methodology, we have recorded videos. I also offer online training via Zoom. And here's an example of the recorded video. So in this project, our aim is to make our citizen scientists to contribute to peer-reviewed publication in order to enhance their academic and professional status. But being citizen scientists, they do not have advanced level of astronomy in order to carry out professional astronomy research. So we sought for some research they can do without advanced knowledge of astronomy, and one of them is on double star research. We collaborate with Dr. Richard Fried, the president of the Institute for Student Astronomical Research in the United States. And in this research, what we do is to update the position angle and the separation of these double stars. We also verify if they are binary stars or optical double stars. So the students write papers, they write manuscripts on their findings and submit to the Journal of Double Star Observation. So far, we have written since this year, 2024, we started this year, we have written up to 12 manuscripts, but 4 have been published. So in the training methodology, we have recorded video like this and online interaction with the research instructor. For the tools, you can use any operating system. You would need internet, you need AstroImagery and other programs. Then we have radio contact to ISS with amateur radio on the International Space Station. This opportunity is going to allow our African citizen scientists to interact with astronauts aboard the International Space Station in order to ask them questions. This is a project that is usually seen in advanced countries. However, entities in South Africa and Morocco also conduct this exercise, but we are the first organization that is going to bring it in the African society, and we hope to make it permanent. So here is an AI generated image of how the event is going to be. The students are going to interact with astronauts via Zoom, and we are getting prepared to conduct this starting from 2025. So in the astrophoto visual development, we teach our citizen scientists how to process space images to produce colorful visuals. So we teach them how to process images from the Hubble Space Telescope, the James Webb Space Telescope, and the Los Cosmos Observatory. So for the training methodology, we have recorded videos, we have online training via Zoom. We have Photoshop training, we have GIMP. So in our telescope giveaway program, we collaborate with GNP Groded and AFIRS in distributing telescope across Africa. And the purpose of doing this is because we are working with a whole lot of teachers across Africa. And some of them, they need this telescope for their teachers training program. So we collaborate with this organization to distribute telescopes to them. Another purpose of this telescope giveaway is that there are some countries in Africa we find it so difficult to recruit citizen scientists. So it means that the astronomy knowledge in those places are very low. So when we find somebody from that place, we give that person telescope for astronomy outreach in order to spread astronomy and also to recruit citizen scientists. Live observation via Sloop Webb telescope. So we use the Sloop telescope for live observation. Here is the dome. We use it to observe the moon, the sun, live, okay? Live observation, not through email. Live observation. We can also use it to observe deep space images. And most importantly, we use it to observe eclipses. Like these are the pictures from the eclipse that happened in North America in April of this year. We're observing it right from Africa while it is happening in America. So here is the map of the world showing the different places in the world where the slow telescope is located. So they have location in Chile, they have location in Canary Island, and they also have location in Australia. They also have mobile telescope. They move around the world for eclipse observations. So in order to evaluate our result, we issued surveys to our group leaders in order to know how they are adopting our project in their classroom. So from the survey, we got that 691 citizen scientists have been engaged across 45 countries in Africa. Mind you, there are about 54 countries in Africa, so 45 out of 54 countries have been engaged. Now, we have about 70 groups. We work in groups, we don't work individual, we work with groups. Now, out of those 70 groups, we classify them according to levels. For instance, A is equal to 15. A represents national space agencies, national astronomical societies, national observatories, and other national entities. B is equal to 25, representing university groups. And C is equal to 30, representing private astronomy organizations and also including secondary schools. So here is the gender identities. Most of the people that fill the surveys identified as male and female. Levels of education, we have secondary schools, we have bachelors, we have masters, we have PhDs. So from here you can see that bachelors have the most participation. And for these PhDs, the PhDs are mostly university researchers and lecturers adopting our project in their classroom and engaging these students. So our particular project, the 4 active ones, from the survey, we discovered that the asteroid search is the most pronounced, although others we recently incorporated them. However, the asteroid search has been with us since the past 3 years. So here is the year of participation of citizen scientists. We started this program in 2020, and the number, we keep recruiting people. The number have been increasing every year by year, and we are in 2024. So there are 5 geographical zones in Africa. So here are the population of citizen scientists from each of these geographical zones. So here is a map of Africa showing the countries where we have expanded our network. The countries in blue are the countries who have expanded our network. We are still looking for participants from Mali, from Mauritania, and Cape Verde, and other countries. So our project has been contributing to 6 out of the 17 SDG goals, Sustainable Development Goals, which are quality education, gender equality, decent work, and economic growth, gender inequality, reduce inequality, peace, justice, and strong institution, partnership for the goals. So we have written papers on about our organization, and also we are writing papers on each of our projects. So far we have written 2, and we are still writing more. So if you want to read everything about our organization that I've just explained now, I want you to go to our website and go to the publication page so that anytime we drop any paper there, you can have a look at it. You can also sign up for our newsletter so that you can receive a notification when the papers are ready. They are still undergoing peer review. So we are looking for collaborators across Africa and beyond. We are looking for collaborators. So if you are interested in collaborating with us, please reach out to us. Thank you so much.
I understand that the speaker is on Zoom, so if there are any questions, we can ask questions. No questions. All right, well, then that concludes this session. Thank you very much for coming. Our next session will commence at 1:30. See you then. Yes.
But you both come to the podium, yeah?
Do you need anything else from me?
No, carry on, sit down. Yeah, I'm just waiting to get the thumbs up from these guys because we can't start without. Yasmin has 15. Yeah. Yeah, just 2 15-minute ones. Yeah. Okay. Okay, I'm going to go for it then. Yeah.
I'm wondering.
Hello, everybody. Welcome to session C2. The key and highlights, the key aspects and the highlights of Division C. It's great to see you all coming. We will start so that we can end promptly. And we're going to start with Sarah Schechner, who is giving some highlights from Commission C3. Please stand up, Sarah. Okay. So it's that button to move forward there.
Okay, and I use this microphone. Okay. Well, good to see everybody this morning. And I am going to talk about how history touches the sky and give a sense of what we're doing in Commission C3 related to the examination of tangible things of astronomy and their history. So, as a science that studies distant celestial objects, astronomy really deals with few things that can be touched directly. And yet, astronomy has many tangible things which link the past to the present, things like scientific instruments, log books, observatories. And there is little question that we should maintain things still valuable for scientific research purposes. But why do we care about documenting and preserving the old and obsolete? Well, one answer is that material things, when closely examined, enhance our knowledge of astronomy's history in ways that written text alone cannot do. And the second answer is that by learning about the past helps us live critically in the present. Historical astronomical objects, when thoughtfully examined and analyzed, as I hope I'll give some examples today, are useful to modern scientists because they offer insight into why things are the way they are, why we believe what we believe, and perhaps how we can change them if that seems appropriate. So let's have a few examples. So I'm going to begin with the adventures of Captain John Smith, Pocahontas, and a sundial. So in 1607, Captain Smith was paddling upstream through the Virginia wilderness when he was ambushed by Native Americans, imprisoned, and prepared for execution. His life, he said, was spared first by the intervention of his pocket sundial, whose spinning compass needle fascinated his captors, and then by Pocahontas, the chief's daughter, who threw herself between Smith and a warrior prepared to bash in his head. So I want to focus on the sundial in this story, perhaps the most famous sundial in American history because of its place here. Smith described his sundial as a microcosm of the universe, showing the Earth's roundness, the course of the sun, moon, and planets, and positions of stars. He claimed that he used the sundial as a prop to lecture his captors on astronomy, geography, and the diversity of nations. While he might question how he did this with the language barrier and all, the point is that for Smith, mathematics was a key to nature, and his compass sundial was among many mathematical instruments that sea captains like himself had used to explore and chart the waters of Virginia and the Americas. Like Thomas Harriot, the astronomer explorer who had 20 years earlier camped in Virginia, Smith understood that mathematical methods gave European settlers powers that seemed magical to indigenous Americans, powers that would enable them to dominate their new world. From these first encounters, English cosmology was set on a collision course with the world of Native Americans. And Captain Smith's tale of his sundial sheds light on the imperialistic arrogance of some of these colonizers and the roots of conflict with Native peoples about cosmology, which is an ongoing situation in the location of mountaintop observatories. So let's now look at an almanac, a sermon, and some mechanical models. The first periodicals in New England were almanacs, which beginning in 1639 were prepared by Harvard College tutors and printed on a press in Harvard Yard. They instructed readers on Copernicus, Galileo, and Kepler, but they also expressed a Puritan worldview that natural events reflected God's will and should be seen as signs of the times. After learning that Harvard's commencement would coincide with a solar eclipse in 1684, the college moved it up a day just to be safe. The academic festivities went on without a hitch, but the college president, John Rogers, died the next day during the eclipse. The owner of this almanac, Samuel Sewell, who you see here, notes the coincidence in his copy of the almanac. You can see it at the bottom of the page there. Now, Rogers' successor as Harvard president was Increase Mather, who was a notable Puritan divine. And in the early 1680s, Mather, who was very much interested in astronomy, viewed the Great Comet of 1680-81 and what we now call Halley's Comet of 1682 with the college's first telescope. The observations of one spectator alongside him, Thomas Brattle, were immortalized in Newton's Principia, whereas Mather put his ideas into sermons and long published tracts. Mather preached that comets were portents of political and religious evils, death and destruction. They were God's warning guns that people should respect. Now, by the time Halley's Comet made its first predicted return in 1759, comets and eclipses did not cause alarm in Boston, just public awe. Harvard's professor of mathematics and natural philosophy, John Winthrop, observed the comet with this telescope. Comets were part of the solar system, he lectured, and yet evidence of God's handiwork and providence. Like Isaac Newton, he said they brought aqueous fluids to the earth and fuel to the sun. Just look how wisely and orderly God had contrived nature, he said, that things aren't smashing into each other. Indeed, when using this orrery and this cometarium to teach astronomy, Winthrop was expected to promote piety. The point here is that popular beliefs in the role God played in the cosmos had changed, but astronomy had not shed its ties to religion. In fact, faith was still a motivator for astronomers and institutions that supported it. Almanacs and mechanical models, when understood in context, prompt us to consider how shifting and diverse religious beliefs in today's world might affect academic and federal support for astronomy, something we are seeing now in the United States. So I'd like to I'm jumping over hundreds of years at a time here. I'm going to jump another 100 years to talk about glass that altered the scale of the universe and the workforce. So I'm going to look at the early days of celestial photography and the time at the Harvard College Observatory of director Edward C. Pickering, who you see here. And Pickering was not so much interested in stars' positions as in their physical nature as revealed by photometry and spectroscopy. Initially, he and male observers took measurements visually at the eyepiece of instruments, but photographs more sensitive than the naked eye soon took over the data capture. Pickering deployed camera-like telescopes in both hemispheres. Notable among them was the 24-inch Bruce telescope, which you see pictured as installed in Arequipa, Peru, which was, and then the lenses as preserved now in the museum at Harvard. It was the most powerful telescope in the world when completed in 1893. And the telescope, after first being set up in Cambridge, was then erected in Arequipa, Peru, at Harvard's Boyden Station, and then in outside Bloemfontein, South Africa, when that station was shifted, in order to photograph the sky on giant glass plates. A single photographic plate could reveal more than 100,000 stars, and comparison of plates taken at different times enabled variable stars to be discovered and analyzed. When an objective prism was in place with the telescope, starlight was, of course, dispersed into spectral bands, and these were used to classify stars according to a sequence devised by Annie Jump Cannon and the woman at Harvard College Observatory. Notes were made in India ink on the non-emulsion side of the photographic plates, on its paper sleeve, and in pencil in logbooks. These annotations leave a trail of how the work was done, by whom, and when. A recent project at Harvard to digitize 500,000 plates had for years been scrubbing off these marks, thereby physically erasing the work of some 80 female analysts who were known as computers, whose contributions to astrophysics were long underappreciated. But I'm happy to say that this is no longer happening at Harvard. They have a new method of digitizing the plates for the last batch, but still there was irreversible loss in the early stages of this project and through most of the project till it changed hands. So let me mention two briefly women working at the observatory. Henrietta Swan-Leavitt specialized in variable stars and examined Bruce plates. Her analysis of Cepheid variables in the Magellanic Clouds led to her discovery of the period luminosity law. Her results were published in 1908 and 1912, and her findings were used in the 1920s as a way to measure the dimensions of the universe, showing it was much more vast than the Milky Way, which up to that time was the only really game in town. Another computer, well known, was Annie Jump Cannon, who personally classified more than 350,000 stars by their spectra and created the Harvard classification, still in use to a degree today. She was the first female officer of the American Astronomical Society, and yet Harvard would not appoint her to a professorship until some 30 years later, right before she died. Thus, the glass plates raise our consciousness about the role and treatment of women over time. The reduction of data from hundreds of thousands of astronomical photographs was time-consuming, and Pickering could not afford to hire more men, so he turned to women willing to work for 25 cents an hour. And they were so essential to the work at the observatory that Harlow Shapley, Pickering's successor, measured projects in terms of kilogirl hours, quote unquote. So in spite of the pioneering work of computers such as Cannon and Leavitt, this 1980 photograph depicts them holding hands in a paper doll-like pose. It's cute, but it's not really very respectful. With instruments readied in Cambridge before being shipped abroad in crates of glass plates returned for analysis, the observatory also, it tells us, had become a research factory. To manage all the observing stations and data streams, Pickering and his successor, Harlow Shapley, employed a rotating desk. Here you see the desk in 1906 when it was brand new, and Pickering is very proud of it. It's 8 feet in diameter, and the photo on the right shows it today. And if you look closely at the desk, you see remnants of a label on a compartment marked Boyden Station. So it tells us how it was used. So the story of glass in the forms of large lenses, prisms, and photographic plates takes us into a global network of observing stations, an expanded astronomy workforce on multiple continents, and at the observatory, the creation of a data library, which can still be mined for information 100 years later. My last example, I'd like to look at instruments of collaboration. A major reason that governments have supported astronomical research is the presumption that it is useful, especially for navigation, geodetic surveys, time finding, and the military. Given the national advantages, it's surprising perhaps that European powers in the 18th century held fast to the belief that astronomy should rise above politics. The expeditions to observe the transits of Venus in 1761 and 1769, which used these instruments that you see here that survive at Harvard, and instruments like them that survive at many other collections, are stunning proof of this commitment. The International Geophysical Year, which ran from July 1957 to December 1958, and so was actually an expanded plus year, had similar aspirations to be the largest multinational collaboration of scientists to date. But the Cold War politics came into play. The United States and the Soviet Union each planned to launch the first artificial satellites to study the Earth's shape and atmosphere. The satellites needed to be tracked, and the job was given to Fred Whipple, an expert on meteor tracking and photography, who was the director of the Smithsonian Astrophysical Observatory. And Whipple planned a two-pronged professional and amateur approach. So first, 12 professionally manned Baker-Nunn telescopes were to be deployed to photograph the satellites in order to determine their orbits. These big cameras, though, needed to know where to look for faint objects. This was the job of Operation Moonwatch. The SAO published inserts in Sky and Telescope magazine that called for the formation of amateurs who would observe the satellites passing overhead and relay their data back to the SAO. They were equipped with modified Army M17 elbow telescopes and cheap satellite tracking telescopes made for this purpose. But when Sputnik launched unexpectedly on October 4th, 1957, the United States was caught with its professional telescopes down, and Moonwatch observations of citizen scientists filled the breach. Project Moonwatch speaks to the importance of amateurs and crowdsourcing in assisting professional astronomers. It also speaks to the entwinement of military, security, and astronomical institutions in the development and deployment of high-tech, classified optical instruments. Now, I could easily go on with more examples of these old instruments, archival documents, and observatories that no longer play a direct active role in today's astronomy, but I hesitate to declare these things obsolete. They enhance our knowledge of astronomy's history in ways that written text alone cannot do. And so we must learn about the past in order to live critically in the present if we are to be the best scientists we can be. So in the next triennium, the Commission C3 hopes to formally establish a working group to promote the preservation and study of astronomy's material objects, a keys to understanding the history of astronomy and astrophysics, and as a foundation for communicating this history to the public. And I hope you will support this endeavor. Thank you.
Thank you very much, Sarah. That was a really beautiful and very interesting talk. A question, yeah, John.
Sarah, you showed a picture of Annie Cannon with one of Harvard's telescopes. not sure which one. But most people think of Annie as someone who spent her whole time just looking through a microscope at stellar spectra and classifying them. Was she also an observer?
Yes, she was. She was rare in being a woman allowed to actually do some observing in Harvard's instruments. And the picture I show is from the archive, shows her with, I think it's the Beige telescope, one of Harvard's early photographic telescopes in Peru. So not only did she observe occasionally in Cambridge, she actually went to Arequipa and spent some time there. But you're right, most of the time she's huddled over those glass plates.
One more quick question. No? Well, let's thank Sarah once again. And can I ask Michael Burton to step up?
Okay, well, going through the numbers, C4 here, and this is World Heritage and Astronomy, and that's actually the title of the work of the commission. I'm actually giving this on behalf of Juan Antonio Belmonte, who's the outgoing president. I'm the incoming president for this commission, but actually I want to acknowledge Goodwin, who's taking a picture of me right now. She's the Goodwin Walshwood. She's the past president, and much of what I'm saying today advised me on to help here. So let me tell you about. Oh, sorry, we're not here. Okay, yep. So my outline very quickly. I'm going to World Heritage and UNESCO. You have to understand something about UNESCO. It's completely different to what you probably ever know or imagine. I need to say a few words about that. I'll give you some examples of where World Heritage has astronomy connected, and then over the last triennial, there's actually been 6 properties. That's the UNESCO parlance. Inscribed by UNESCO where there's some kind of astronomical connection. I'm very quickly going to tell you about those. And then I want to start talking about some future candidates. And essentially, this is where the work of the commission might come in about helping candidates along. That's where it goes. So first thing we've got to do, get in mind, though, is what we mean by heritage, and particularly what relates to world heritage, because that's only one aspect of a much broader field of heritage. It could be fixed objects, monuments, observatories, it could be movable objects, instruments in particular, it could be intangible things or intangible things, the ideas or the cultural significance of the dark skies. And you could spend a whole talk about what these things all mean. When it comes to UNESCO World Heritage, what we're essentially talking about are fixed objects, tangible objects, and they're essentially some kind of structure. That's the central concept here. It doesn't mean it's the only concept, it's the central concept. So this is what UNESCO describe as World Heritage. I'm just going to read it out because it's well worth picking the words. Heritage is our legacy from the past, what we live with today, what we pass on to future generations. Our cultural and natural heritage are both irreplaceable sources of life and inspiration. What makes the concept of World Heritage exceptional is its universal application. World Heritage sites belong to all the peoples of the world, irrespective of the territory in which they are located. So that is the central idea. What does that mean? Well, that's what we're going to come to. In practical terms, though, to get to World Heritage, you have to be nominated by a country, you're examined by a series of experts, and then ultimately voted on by the members of UNESCO, which is basically a group of diplomats, about 20 diplomats who represent UNESCO. That takes about 10 years. So this is not a short process. But to get there, the central concept for UNESCO World Heritage is this idea of something called outstanding universal value. OUV only occurs when UNESCO says it does. I'll come and tell you a little bit about that in a minute, but there are 6 cultural or 4 natural criteria. You have to meet one of those essentially, but hopefully, ideally, you meet more. But there's more to it than just that. Once you've got OUV, there's a concept of authenticity. Basically, what you've got is actually a real representation of what's out there. Integrity, what you've got represents whatever it is that you're claiming the heritage for. And then, and this is where much of the work goes into, you've got to have a management plan and you've got to know how to protect it. And so all that is why it takes 10 years to get to World Heritage.
UNESCO define their OUV criteria. I've listed here 5 of them, which are the 6 which are relevant for culture. The reason I've just listed 5 is these 5 here have all been used in one part or another by some of the properties which have already inscribed, which have an astronomical connection. I'm not going to read them all out, but the kind of ideas you can see in there put in yellow, for instance, development and architecture or technology, that's in criteria 2. On criteria 4, an outstanding example of a type of building which might be a technological ensemble, which is significant in human history. And then there's actually number 6 out there, which is actually an intangible one, and it's about ideas of outstanding universal significance. That one can't lead a nomination, but it can certainly support it. It's an intangible one, but it can, of course, for astronomy, our new ideas are central to what we do. So I'm going to very quickly give you some examples, some well-known examples, and perhaps some lesser-known examples of sites which are already in there. And perhaps the most famous of all are these alignments of these essentially megalithic monuments going back 5,000 years or so. In the UK, there's Stonehenge. In Ireland, there's Bryn or more commonly known as Newgrange. And here the alignments are generally with the solstices, the winter solstice, the summer solstice, and Stonehenge. It's both of those. The alignment along the Stonehenge Avenue, along those, basically you can see the gap between the monuments there where the sun shines on those days. In the bottom in Bryn there's this roof box, and there in the lower picture is actually from the roof box. On the winter solstice, the sun shines right down that. So there's clear, basically it's clear understanding of the cultures who built these, of these celestial cycles in some ways. What they mean is another matter, but there's clear understanding because the buildings have been put around the astronomical phenomena. Another very famous site, Greenwich, the Royal Observatory in Greenwich, that is on the UNESCO list. It's not really on the UNESCO list for its astronomy. It's an important part of it. It's actually there for its contribution to the maritime culture and traditions of Britain at the time. But of course, navigation was critical for that, and the Royal Observatory and the meridian and the Greenwich time, and all those concepts come from it. But maritime Greenwich is certainly one of the ones. 2 which you perhaps might not be aware of, but and these actually essentially represent the development, the uses of naked eye astronomy pre-telescope, even though one of those is obviously post-telescope when it was there. But in Uzbekistan, in Ulugh Beg, there's remains of a quadrant from a meridian arc, basically positional measurements of stars. And then in India, the Janta Manta, where there's 20 massive fixed instruments which are there essentially for measuring stellar positions, and these are on the World Heritage List. But a game changer came in UNESCO, at least in relation to astronomy, about 5 years ago, with the successful nomination of Jodrell Bank Radio Observatory, which is an active research organization. I mean, the main dish over there is used every day for frontline science, and it's also where, very appropriate for this meeting here, the SKA, the headquarters of the SKA, in the middle of this site. It's actually excluded from the World Heritage Zone itself, but it's right in the middle of the site. But in fact, it's not on the World Heritage List just because of the great dish. All the stages in the development of radio astronomy over a period of like 50 years can still be seen in buildings and instruments which are still left around the site. They're not particularly architecturally very attractive buildings. They're basically mission huts and things like that. But the stages of development of science still exist today, and that's the critical part of it. And that's what got the UNESCO listing. And also it's science. And actually the S in UNESCO stands for science, and UNESCO hasn't had science to its fore. So it's very significant that. So what I want to do now, very quickly, over the last triennium, last 3 years, there have actually been 6 properties nominated and successfully inscribed by UNESCO, which have some kind of astronomical connection to them. There's many other properties which have it, but I mean, have been inscribed, but there's 6 which have it. I'm just going to very quickly have one slide on each, so you get an idea of the kinds of things which are being put forward. These are not put forward by the Commission, I should say, though sometimes members of the Commission do get asked to provide advice on these things here, but these come from the countries involved in them. So perhaps one of the most spectacular ones is this one here in Purfeld. I think I've seen pictures of this put out elsewhere around there. These alignments, this calendrical instrument, where basically over the course of the year through those towers, you can see the sun pass through, and you can essentially measure the date to a precision of about a couple of days, and it has the entire course of the passage of the sun over the year. This goes back, but getting on for 2,000, over 2,000 years ago when this was actually inscribed. More recent one, this is in Spain, in Madrid, in fact, the Paseo de Prado and El Retiro. This is essentially, it's called a cultural landscape of arts and sciences in Madrid. There is the Royal Observatory in Madrid. There's one of many buildings inside there. The astronomy per se is not part of the criteria. It's a whole landscape of the arts and sciences. So indeed, in the Royal Astronomical Observatory, there is actually a William Herschel telescope in there, restored, and I believe one of his last telescopes inside there. So there is that astronomical connection there. Another one which goes back to ancient times, this is in the Balearic Islands in Spain, the Teleotic Menorca. Basically that T-shaped object there is what's called a talaiot, and the orientation of these talaiots is connected, at least that's what the inscription says, connected to astronomical orientations, basically looking at south and looking at some of the things like the Southern Cross connections there. So this connection with the sky is part of the nomination that goes forward. And then this one here, this is a very interesting one that was nominated. This is in the Netherlands. It's actually a planetarium, or at least what was called a planetarium at the time. We call a planetarium something different now, and we now call this an orrery. But basically, it's the roof, and it's a mechanical model of the solar system. This goes back to the late 1700s, 1774. It's a scale model of the solar system as it was known at the time, and it's still there today and still in working order. It was basically made by a private citizen in the ceiling of their house. And it's still there, and this recently got inscribed. And then there's this one here, which is in Russia, got inscribed, and essentially this represents this observatory here at Kazan. There's actually two observatories in it, one in Kazan city and one in a place called Engelhart, which is, I believe, a suburb nearby. And it kind of represents the transition from the classical observatory to the modern observatory. There are a number of instruments associated with that that got nominated and succeeded. And then there's this one in the USA. I was completely unaware of this one was nominated. It's in Ohio, in fact. And these earthen enclosures go back around about 2,000 years ago. And again, there are alignments you can work out with the sun and the moon, more complex ones of the moon, in the orientation of these ones here. So 6 ones which have been nominated successfully. But I want to now turn to what might happen in the future. And indeed, there are a number of observatories around the world where there's interest in developing cases for UNESCO. Now, these are long processes, and there's all sorts of complexities in them, but I've just shown 4, for instance, here, which I'm aware of. There's probably other ones where people are interested in. But for instance, actually, I'll start at the top left over there. That's actually not an observatory, that's a planetarium. And that's actually the oldest planetarium in the world. It goes back 100 years. It's in Jena in Germany. And indeed, the planetarium industry, and I'm a fan of planetariums, so I have an interest in that myself, is now the centenary of the first modern planetarium. And this is the oldest one in existence. And then we have 3 well-known observatories, La Plata in Argentina, Hamburg in Germany, and indeed right here in the Cape. And there's all potential there for World Heritage. The question is how we make that case. And it's not a case of simply putting one observatory up and just saying what a great place it is. There's a much deeper story which will need to be told, but these are the kind of challenges which we can try and take on. What I do want to talk about, though, and I have to declare a personal interest in this because this is where I work, and here I'm the director of the Mao Observatory in the top right. And I wanted to point out my colleague Peter Gallagher, who's down at the bottom over here, and he's the director of Dunsink Observatory on the left. He's also the chair of the trustees, basically the board for the Bird Telescope on the right here. And we have come together at the 3 observatories in Ireland for what we call the Astronomical Observatories of Ireland. And we are in the process of putting together a bid for World Heritage. We've actually written what's called a tentative list application. The first stage of the process is you have to get to the tentative list of the country of nomination. We haven't quite submitted it yet, but it's basically written. We're almost ready. And in our process, this will go through Ireland, but actually be a transnational nomination involving the 2 jurisdictions on the island of Ireland, which is the UK and Ireland. But in a nutshell, what is behind our nomination is that this is the origins of the modern observatory. The two towers, you can see, in fact, the three towers, there's two there in Armagh on the right and one in Dunsink on the left. These are the beginnings of the astronomical dome, which is supported through a pier going into the Earth, where it separates the telescope from the building, so the building being designed around the needs of the science itself. And that starts with these observatory domes in Dunsink, in Armagh. And then the telescopes which exist in them, you can actually see the development of the equatorial telescope itself over a 100-year period from 1795 to the end of the 19th century. Basically the beginning of the equatorial telescope to the telescope which produced the NGC catalogue that still works today. You can see that. And then, of course, we have the Great Telescope, more commonly known as the Leviathan, the one in Burr on the bottom right, which was 6 foot across. It was feet in those days. It was the biggest telescope in the world for I think it was 75 years or close to 75 years. Amazing telescope. Essentially, not a transit-like telescope. It wouldn't look across the whole sky. It was also responsible for the discovery of the enigma of the spiral nebulae, what basically became galaxies. The concept of galaxies began with the discovery of the spiral nebulae. It still took nearly 100 years before the first drawings turned into the great debate and Harlow Shapley and all those stories in the 1920s when the concept of galaxies became enshrined, but it started there. So all those concepts there are what's going to form the basis of the application we've been putting forward. We basically, it's about the domes and the observatory, the telescopes themselves, and then about our place in the cosmos, which is the discovery of galaxies. So this is the application, which I hope is going to be at least got to the first stage before the end of this year. But as I say, this is a long process. So what are we going to be doing? Or okay, we're getting near the end. So I just want to say a few more general words about the Commission itself. And in particular, there's a great resource of information about heritage in astronomy, not just UNESCO heritage, but heritage across there. In fact, Gudrun looks after this. There's a website, I put it up there. And in fact, every single dot there, there's an entry it's put in there. And Gudrun's always after more information. If your favorite historic observatory is not there, we can always add information to it. But it's a great starting place as a resource for some of the astronomical knowledge. And that might help us try and identify what we might try and do in the future in terms of bringing things forward. And we're not starting in a vacuum. There have been a lot of studies already, in particular two what are called thematic studies, which were sponsored through UNESCO through what's called ICOMOS, which is the International Council on Monuments and Sites. And there's quite comprehensive treaties there going through many of these observatories and talking about some of their features. So it's a starting point for there. So I said it's good. And actually, I should also acknowledge Clive Ruggles, who's also contributed. He was the founding past president of this commission here. And essentially the whole concepts come from there. So just to finish up with then the kinds of things this commission can help and do. First of all, it's advising about World Heritage potential. If you've got an idea, you can at least you can take it to us, and we can say yes, there's a hope, or no, there's no hope. I mean, at least we can start you on the process of what's there, because it is a minefield understanding what there. It's taken me 3 years to get this point myself. There's also other sites around the world which are on the World Heritage List, which actually potentially have astronomical heritage associated with them, but it's not actually in their OUV. And that's add the OUV with astronomy. And finally, identifying new sites which could be included going forward and how we start the process off there. That's the kind of work of this commission. With that, I'd like to finish. Thank you.
Thank you very much, Michael, and thank you for that interesting talk about the important work of the Commission protecting our astronomical heritage. We've got time for a quick question. Anybody? Yeah, at the back there. I think there's a mic on the table. Yeah, grab that one.
Mic check. Whoa, does work. Hey, Dr. Burton. Michael O'Shea here. I had a great chat with your colleague, Matthew McMahon.
Oh, McMahon, yes. Well, he's doing a PhD on all this stuff.
Yeah, great stuff. Learned
yes.
so much from him.
Yes.
So it's good to meet the director here. And in talking to him, I learned about the construction dates of the Leviathan at Burr Castle. And what I was struck by is those dates coincide with years of the Irish famine, right?
Yes,
so
that's a very interesting observation, I should put
so
it
it made me think about not only my own history, as I'm of Irish descent, right? but how the construction of these telescopes relate to, you know, who has power, who has politics, who has wealth.
Do you want to talk to that?
And how that might connect to other
Yes.
right relationships around the world.
Yes.
Thank you.
No, it's. I'll let Peter. Can you just? Peter looks after Burr and knows this.
Oh, wow.
But so this is this
He's
is
the right person to ask.
But this is a very relevant question.
Thank you.
Well,
Yeah, thank you for the question. The Great Telescope, or the Leviathan, was built by the third Earl of Ross and his wife. The two of them worked together very much on it before the famine. And then during the famine, they actually, there's a letter from the third Earl to the Royal Society where he says, we're stopping doing our work and our observations to focus on famine works, where they then directed their vast wealth to famine works, which involved employing lots of people to work on the castle walls, to build things and so on. But they were, they did an awful lot of good during the famine, which is commonly not understood, but it also gives you some reason why they still live in the castle. The descendants are still there because a lot of stately homes and castles would have been attacked or burned down in the years after the famine. So hopefully that clarifies that question.
Thank you.
I'm afraid that in the interest of time, maybe John, you can catch up with Michael afterwards.
Okay.
All right, can we please thank Michael again, and can I ask Steve Goldberg? So next up, we have Steve Goldberg, who's going to be telling us about a new commission just starting, Commission C5. So it's that one.
See if everybody can hear me. Yes, and that's I'm Steve Goldberg from the University of Oklahoma, and it's a great pleasure today to introduce the IU's newest commission, which is Commission C5 for Cultural Astronomy. Cultural astronomy examines the astronomy used in ancient contemporary cultures, including orientations found at sites and structures. It has both archaeoastronomy and ethnoastronomy, and Michael already gave an introduction to Chenkio, and these massive towers with these great staircases this is a little closer look at what he showed you just previously. And UNESCO asked me to be one of the reviewers of the proposal from the Peruvians to put this on the World Heritage List. That's my wife, Jessica. She's a gifted artist. She illustrates everything for me. That's the June solstice sunrise that she painted in watercolor at Chenkio. So what is archaeoastronomy? That's better. Archaeoastronomy deals with the astronomical significance of sites and structures. Its studies are interdisciplinary because you have to put them in the cultural context. So it includes also elements of archaeology, anthropology, and it investigates possible alignments in cultural associations, but it must be intentional. And that's why you have to have cultural context. And ethnoastronomy deals more with living indigenous peoples and their astronomies and how it affects them and their cultures. But intentionality is still an issue here. You have to determine what is their myth and what is supportable. Myth is okay, but you just don't represent it as scientific fact. So this brings us now to Commission C5 for Cultural Astronomy, which is of course here part of Division C. And here's our initial officers and organizing committee, myself, Alejandro Lopez from Argentina, Suzanne Hoffman, Germany, Javier Mejudo, Honduras, and Danielle from United States, Juan from Spain, a lot of you know him, Kelly Blumenthal, of course she's the US, but she's the director of the OAO in Japan, Rita Gauchi, Switzerland, Cesar Gonzalez from Spain, Dwayne Hamaker, Australia, Seiko Hayashi from Japan, Clive Ruggles, who's one of the elder statesmen of archaeoastronomy, so it's wonderful to have him with us. B.S. Shalaja Johnson Yarama from Nigeria. We're coming from the working group for astronomy and culture. It grew to be very large. We had 120 members in the working group, and I won't go through all their names here, but this is just to give you an idea that the working group had grown to be the size of a small commission, which was partly what headed us in this direction. And you'll see as we go through this, most of the images, not all, but most are either my research photos or my wife's paintings. So cultural astronomy, indigenous astronomy, is perhaps one of the oldest sciences describes the way ancient peoples used it in their daily lives for timekeeping and other such functions. It's been used for activities like when to plant and harvest, to anticipate seasonal changes, and also for timing of annual religious observances. It's now it's emerged as a scholarly field of study. Cultural astronomy examines the production of knowledge about the sky linked to the socio-cultural manifestations of peoples, with addressing cultural diversity in the context of natural science. In the history of it, it's an infant as far as scientific fields go. It just really got off to a stronger start in the 1960s and 70s. There was an occasional book or publication before that, but that's when you really started seeing it come together. The first time the word archaeoastronomy may have appeared in print that we found was on January 28th of 1971 in BBC's The Listener. But then in 73, Elizabeth Beatty published a paper called Archaeoastronomy and Ethnoastronomy So Far, introducing the term ethnoastronomy a little more and furthering archaeoastronomy. And then the studies continued to expand into the 90s, and cultural astronomy began to emerge. The first specific conference for archaeoastronomy was held in Oxford in 1981. The series continues every 3 to 4 years, currently known as the Oxford Symposium on Cultural Astronomy. As the field continued to evolve, organizations, of course, professional organizations emerged: the European Society for Astronomy and Culture in 1992, and the International Society for Archaeoastronomy, Astronomy and Culture in 1996, with the help of the Center for Archaeoastronomy that had been established at the University of Maryland in 1978, which and the center also published the first peer-reviewed academic journal for archaeoastronomy called Archaeoastronomy, the Journal of Astronomy and Culture. In the early 1990s, the term cultural astronomy was introduced by Stan Iwaniszewski and then by Clive Ruggles and Nicholas Saunders, after which the use of the term cultural astronomy increasingly gained wider acceptance, as evidenced by its use in names of emerging societies and journals. Clive once posed rhetorically, why is cultural astronomy relevant to modern astronomers? Well, it extends well beyond the history of Western scientific astronomy. It fully embraces the anthropology of astronomy, as it explores how cultures perceive what they saw in the night skies above them and how they put this knowledge to use. So for the Commission, our rationale, cultural astronomy has matured as a distinct field of research and will now be even better to elevate its contributions as a regular commission of the IAU. The new commission embraces all goals of the strategic plan, but are especially poised to enhance efforts with goals 3, 4, and 5, because cultural astronomy is very much an attention getter for the public and also a fascinating way to introduce students to astronomy education. And we'll be working to develop even more solid relationships with the OAD, OAE, OAO, and OIA. It's important to note that, once again, the distinction between history astronomy and cultural astronomy, while history astronomy not exclusively, but quite strongly is the academic study of the histories and chronologies of the evolution of Western astronomy and astronomers, observatories, radio telescopes, and such. Cultural astronomy is the astronomy and how they were used by cultures across the globe, living and those that no longer exist, and the way it inspired their vast myriad of their related beliefs and methods. So I've said this came from the Working Group of Astronomy and Culture, which was first founded by Ray Fuller in 2015, and then I took over in 2018. And the name was shortened to just the Working Group for Astronomy and Culture in 2021. The activities include many areas of cultural astronomy, and membership greatly increased. So as I mentioned earlier, we were already functioning in some ways similar to a commission. One of our activities in the working group that will now go on to the commission, the executive committee had us form a joint committee with the Royal Astronomical Society and the American Astronomical Society for culturally sensitive sites. And that started in November of 2020. But the objectives there are to provide insight for Indigenous sensitivities at the various observatories and sites that have been built on grounds that are sacred to the indigenous local people. And also, upon request, help future efforts with best practices and for site selection, responsible site selection, so that they can avoid some of the problems that have occurred at some of the locations so far. There were also in Division C, we had a working group for ethnoastronomy and tangible astronomical heritage, and this is being absorbed into the new commission as well. And they're closely related, the two fields, so it'll be good working together. And C4's working group for astronomical heritage and danger is blending into the new commission, but the new commission is going to work very much to continue to give this kind of support to the work of C4, and the chair of this working group is the vice president of the new commission. The activities of the commission will be such as continuing research with archaeoastronomy, ethnoastronomy, also intangible astronomical heritage, contemporary cultural astronomy too, such as astronomy and contemporary literature, poetry, music, films, etc. And just cultural astronomy of developing nations and how astronomy has been used in their cultures. Education, of course, supporting the OAE, and also upon request the OYA with cultural astronomy lectures, and continue to lend support to the NASE within the working group for key initiatives, the working group for star names, astronomy day in schools, which we talked about earlier this morning. Outreach, and I said Kelly Blumenthal, she's on our organizing committee, will be using cultural astronomy in different ways to help promote outreach, especially because it really is inspiring to the public. And working with Kevin and the OAD for his projects that have been involving cultural astronomy. So just a few examples here from my own research of which my primary area of research is with the Incas. And you'll notice as I go through these slides, I've started using the preferred Quechua spellings of different words rather than the spellings that the Spaniards assigned when they first conquered the Inca Empire. So Inca here is spelled with a K instead of a C. The Incas learned the cycles of solstices and equinoxes and used that knowledge for their annual crop management and religious celebrations. To understand Inca astronomy, though, it must be placed into context in the greater society. Why was it important? Why was it used? How was it used? And these are the questions we ask about any culture around the world that we look at. Pachacutec, which is the Quechua spelling for Pachacuti, the name adopted by Inca Yapanqui, it translates as transformer of the world. And in Quechua, Pacha means a moment or interval in time, and a locus or extension in space, and Kudek is to turn around. So Pachacutec saw himself as the son of the sun and the co-creator of the land, and the Incas believed that their emperor, their leader, was the son of the actual sun in the sky. They were very much a solar worshiping society. This calendar used the position of the sun on the horizon for times of planting and harvesting for religious celebrations. Their biggest festival of the year, the Inti Raymi, which translates as Sun Festival, was the Incas' winter solar festival at the time of the June solstice, still celebrated with great ceremony in Cusco, which is the Quechua spelling of Cusco today. It was a festival for the masses. It brought many pilgrims to Cusco. An elaborate ritual took place over many days, and thanks were given to the sun and prayers and aid for the crops. Inti Raymi is still held on June 24th. And I've been there for that, and it's quite a sight. Tapak Raymi was the summer festival of the sun at the time of the December solstice. This was a celebration for crop germination at the beginning of the season. It was also the annual time for Inca adolescent males to undergo rituals of coming of age. It was primarily celebrated by the nobility rather than the masses. Now, the Spanish chroniclers recorded there had been 16 solar towers built around Cusco for measuring for tracking the position of the sunrises. But the Spaniards, the Catholic priests, had them all eradicated during their extirpation of idolatries. But 2 survive on the north side of the Sacred Valley, and above Quespihuanca, the Palace of Huaynacapac. And as viewed from this sacred boulder in the center of the palace grounds, this looks up to 2 towers. This is a magnified view here of the Quespihuanca pillars on the Saracewa Ridge. And here, this is just a few days before the June solstice sunrise. The sun has been rising and moving from right to left, and it's crossing the left pillar here, and it continues to move toward the right pillar as the solstice occurs. And then, of course, it will go back after the standstill in the other direction again. Kenco Grande was one of my favorite sites to visit. It's a large limestone outcropping. You can see there's a whole lot of people can stand on here at the same time, but this is a great light and shadow effect. Often, just off of the lower edge of here, there's a crevice that allows light from the June solstice sunrise to shine first on one, then the other gnomon, forming these ears for the face of the puma. The puma is one of the 3 sacred creatures of the Incas: the condor for the world above, the puma for this world, and the serpent for the world below. And inside Kenco Grande is a cave with an altar with stairs on the far side. And at the time of local noon, at the time of the June solstice, a few days before and after, the sun will climb the stairs like this and then point to the altar for whatever ceremonies that they had in mind for it. Not too much further up the hill above Cusco from Kenco Grande is Laco, another large outcropping. This has got 3 caves with interesting orientations in it. This first one, the southwest cave, it's got a small altar with a light tube, and I was in there at the altar and was able to photograph the crescent moon crossing the field of view. And the northeast cave is aligned for the opening is aligned for the June solstice sunrise. The sun will keep rising. It'll stop here at the standstill, illuminate the cave, and then it moves back again. And the southeast cave has a multi-chamber cave, inner chamber. This has got a light tube that's oriented at the time of the zenith sun and illuminates the altar nicely. Not too far from either is Waka 44. Waka is what translates roughly as a shrine, but it was more than just a shrine to the Incas. But and there's this large carved cylinder and this smaller one. And what's interesting here is these imaginary tangential lines between them and across them show the Incas where on the horizon to look for the June solstice sunrise, equinox sunrise, December solstice sunrise, and the sunset positions. And there's the big cylinder, the little one, that line pointing to the June solstice sunrise. Machu Picchu, and that's the Quechua spelling of Pichu instead of P-I-C-C-H-U, is very interesting also. And basically, the sacred plaza at Machu Picchu is here. And across 5 kilometers across the gorge is the Yactapata Sun Temple and the river Intihuatana at the base of the gorge below it. But they're all on the axis of the June solstice sunrise, December solstice sunset. And there's the temple of 3 windows and the sunset behind, the sunrise behind it. And there's the Yactapata Ridge. And there's over 100 structures that were found there in 2003, totally engulfed by the cloud forest. We need to use machetes to get to it, except for the sun temple, which was kept clear. And you will notice this beginning of the stone channel here, because the stone channel is pointed across the gorge back at the sacred plaza. It was thought that there could have been ceremonial fluids flowing down there to energize the sun, to keep it from descending in the winter below the horizon. They also were looking for the Haleic horizon of the Pleiades. That's the river Intihuatana in the gorge below, looking back up at the Machu Picchu Sacred Plaza, Intihuatana. Inca constellations. I'll have to go quick here. They've got, looked at individual stars. They looked at the kind of connections that we do, the stars forming bright and dark areas of the sky, and they had mixed constellations. The Pleiades, their Colca was their most important constellation that they tracked. And they had dark constellations in the Milky Way. And my wife's painting here I used, this is their pantheon, the Machaquai, the serpent, Hampatu, the toad, Utu was a Chinamu, a bird, that's also what we know as a coal sack, the mother llama, the baby llama, the fox, and the shepherd herding them across the sky. So cultural astronomy is now a robust field, and the activities from the, like I said, the working group broadened, and further contributions will be better accomplished by the commission. And we look forward to a significant increase in membership. Anybody who's even casually interested is invited to join us. If interested in more, that's my first book, but the second book here that's coming out from Springer just in the next few weeks is made from the oral traditions passed down since the time of the Incas. My co-authors at Quechua, descendant of the Incas. My wife's art, those are not paintings, or not photographs, those are her watercolor paintings. I always have to give her credit, and the Stellarium asked her to paint the Babylonian constellations, so they're in there now. There's 33 of them. Here's some examples. But I thank you, and there's not much time left for questions, but
yeah, well, let's thank Steve. Yeah, so we actually have run through all of our time, but let's thank Steve again for such an interesting glimpse at this new commission. And can I ask Yasmin to step up, please? So I believe that Yasmin Cruceo is going to also be joined by Tim Spuck, but I am assured that they will take no more than their originally allotted time, even though there are two of them. We will. So, so there's your tip.
Hello, everyone. Thank you all for being here. Today I'm here with my colleague Tim Spock to talk about one initiative that we run that is called Cosmovision of the Pacific, Advancing Indigenous, Non-Indigenous Collaboration with Integrity. Just make a detail, I am the Senior STEM Education Specialist at AUI. I'm based in Washington, DC. I am originally from Chile, and I also am Mapuche. Mapuche is one of the indigenous communities from the south of Chile. So as I'm indigenous, I want to say some words, and I welcome in Mapudungun, which is Mari Mari Lamien, Mari Mari Kupuche, Inche Yasmin Catriteo. And at the same time, as an indigenous woman, I want to give a small acknowledge to the indigenous communities from the land where we are today. I didn't want to prepare anything, but like from the bottom of my heart, I just want to say thank you to those indigenous communities that are from here. Thank you for the braveness. Thank you for keeping their life, their culture, even though we all know history and we know what happened with colonialism all around the world. But the indigenous communities from this area, they're strong. They had a beautiful culture, and I'm so happy they're having this meeting today here in this continent, learning so much from them. Which one is it? Ah, the big one, okay. So Cosmovision of the Pacific is a collaboration with other two institutions. At AUI, all the projects and initiatives that we have, we do put our ideas together in collaboration with other institutions. In this case, we are collaborating with the Indigenous Education Institute. From the EIE, we have Nancy Mary Boy, David Begate, and Polly Walker. All of them are indigenous from the Navajo, New Mexico area in the United States. And the other collaborators are the Imiloa Astronomy Center in Hawaii. From the Imiloa, we have Chad Kalepa and Kayu Kimura. I also want to take a moment here to say thanks to Kalepa. Kalepa is being with Cosmovision of the Pacific from the beginnings, and to those who knows, he sadly passed on a few years ago. And the spirit of Kalepa and the vision that he had and how to bring community and how to bring indigenous and non-indigenous together is part of this initiative as well. So for our Cosmovision of the Pacific, I will say that we got started to talk about this long time ago. We started talking about Cosmovision from 2019, and it took a lot of time to come together in order to identify what are our objectives for this meeting. We have identified that first we would like to develop a network, an international network that brings indigenous and non-indigenous together. We all have our own beliefs when it comes to how to do science. We all have our own beliefs when it comes to indigenous science or education. But Cosmovision of the Pacific wants to bring in a network and bring those people together. They're not on the extreme of the thinking, or they're not on the extreme of living on the side, other ways of knowing. So everyone who would like to be part of Cosmovision, or who has been part of Cosmovision so far, are people that are in the middle, that they have their own beliefs. They are open to learn from other beliefs as well. Another objective is identify opportunities. The idea is that based on those beliefs and based on those different ways of knowing, there are things that can bring us together. And through finding that concept or that passion or that knowledge that can bring us together, we can start then building new projects and initiatives. And last, it will be to develop a guide to collaborate with integrity and under a co-creation concepts. Sometimes it's not easy, even for when you're working with your own team and you want to do a project and you have a great idea and you want to approach the other professionals that are with you. Sometimes a little bit hard to go and talk to them. And I don't know how I can talk to them. I don't know how effectively and respectfully I can include more people or other professionals into the work that I'm doing. So when we think when it comes to indigenous and non-indigenous, I think sometimes it gets harder. How do I properly include or invite someone to work with me or be part of my ideas? So we're working together under the Cosmovision of the Pacific to create a guide that can help people to work together. If you're an indigenous and you are now working a project with a non-indigenous, how do you properly approach? On the other way around, if you are non-indigenous, indigenous, and you want to collaborate, how do we do so? So hopefully by the work that we're doing under the Cosmovision of the Pacific, we can create those guidance that can help a lot of people around. Other concept that I want to share with all of you today is that when we talk and when we work around indigenous knowledge, there is this word that is called cosmovision. And cosmovision, it has different meanings or significance for people. I don't think there is one concept that can define cosmovision for everyone. So based on that knowledge, the leadership team came together and we started talking about, so what is our cosmovision? Because we as a team, how do we see and how do we interpret the world that surrounds us? If you go to indigenous people in the south of Chile, like Mapuche, we have our own cosmovision of the universe. We have our own constellations. And based on what we observe, we give it an interpretation that is not only based on observation, but it's also, that interpretation is also being affected by the surrounding area. The cosmovision of the universe from one community set in the south of Chile, it's going to be a little bit different or very super different from another indigenous community that's in another location in the world. So we as a leadership team, we wanted to come together to a definition or a concept of cosmovision. And this is what we have come with. We define cosmovision as an individual of culture way of knowing and being, emanating from the holistic natural cosmic process that has led to the present state of the universe and what is yet to come. Something also that I want to clarify with when we talk about cosmovision, cosmovision is not only about the sky, it's about everything that surrounds us. In Mapudungun, Mapuche, we say your cosmovision is everything what is up of your hair, under your feet, and all around you.
Okay, I'll give you that then.
Okay.
All right. Yeah. So a couple of the points here.
Cosmovision's phase one was an initial effort funded by the Heising-Simons Foundation to bring together about 30 indigenous and non-indigenous persons to explore the space, the collaborative space that we could co-create. And I think it's important, one of the things that Yasmin and I talked about and in these presentations, we want to reflect this, that this is, Yasmin is indigenous, I am non-indigenous, and we want to co-present, we want to co-create. Cosmovisions was designed specifically with the understanding that there is a spectrum. We have Eurocentric on ways of knowing on one side. We have indigenous ways of knowing on the other. There are some individuals who are indigenous who are firmly grounded in their ways of knowing and understanding, and they may not be interested in this sort of collaborative approach and co-creation approach. There are individuals on the Eurocentric side that are well grounded, and they may not be interested in the indigenous ways of knowing and knowledge building. But what we wanted was this space where we wanted to bring together people who were interested in collaborating and sharing what was shareable, and to respect what is not shareable, regardless of what side that you are on. And that's what we did here. So this took place in January of 2023 at Northwest Indian College, north of Seattle. And we did this in sort of a test case, a pilot for what we hope is going to be a much larger Cosmovisions gathering phase 2. And the idea here is a lot of work with indigenous communities has been approached, or a Eurocentric approach is transactional. Like here, we're gonna look around the planet, we're gonna find out where the best place to build X is, and then, oh, there's an indigenous group there. Okay, we need to go talk to them. That's a transactional relationship. That is something where it's like, you have what I want, I've got enough money and resources, I can come and buy it from you, and if you don't want to sell it to me, I'll take it through policy or things like that. That is not the best approach. And so what we are doing is really trying to, through this approach, is to build a network of individuals who have established a relationship, and let's allow projects and efforts and initiatives to emerge out of this that are really authentic, that are co-created because they are founded and grounded within a co-creation process. So that was something that was very important. We had an excellent meeting. There were, we started it off in opening up with an authentic recognition that, hey, people like me are responsible, or people who look like me are responsible for the deaths of, or at least in part responsible for the deaths of more than 50 million indigenous persons in North America over the past 100 years. That's a reality. We had also some other recognitions there, and what we did was we approached it in an authentic way. There were major ideas that did emerge out of this, which is that we need more advocates, we need champions on both sides of the fence to try to champion this co-creation, co-collaboration. There is a deep-seated sense of trauma. And if we've ever worked with individuals who have been traumatized, we realize that that means that they very often are going to be on the defensive and for just cause. And we have to recognize, accept that, and work through that. We also recognize that language was something that was really critical with indigenous communities. We broke off into different scenarios, and we actually looked at how Western or Eurocentric approaches, what they did. What about indigenous approaches? And it was interesting because Eurocentric was very logical. Okay, well, what do we need? What's the next step? How do we do this? But when we got to the indigenous group, when they did their report out, it was, how is this going to affect my culture? How is this going to affect my language? How is this going to affect my family? And that was what was first and foremost. And we need to recognize that and honor that. So then the writing team met, and we produced what was called a phase 1 report. And this here was, this is our framework: deep listening, respect, integrity, that emerged out of this. We have the document, it's on our website. You are welcome to go download it and view it. And Yasmin's gonna close out by just telling you about Cosmovision's phase 2. I do wanna recognize Anika Miller-Rushing from AUI, who has also recently joined the team.
Thank you, Tim. How much minutes do we have left? Oh, okay, so if I can go back a little bit. Oh yeah, the only thing that I want to add to what Tim was saying about this framework that is here, just as a tip, if you are looking to collaborate with indigenous and non-indigenous, or even not only with, if you're just looking to collaborate with your group, when you want to build a project together, it's very helpful to bring the people in your team and just build your framework, your frame or your core values. They're gonna be supportive of the work that you're gonna be doing with them. But you gotta build or identify those values with them. It's not like you bring, these are the core values that I think they're gonna be, what we're gonna use through the project that we're doing. No, you gotta identify those values with your team. And so what comes next? Next for Cosmovision of the Pacific, like Tim said, we're looking to have a bigger meeting. If we compare with phase one, we now on phase two, we're looking to have about 100 people that can come to Kona in Hawaii to walk the middle together and to share what is shareable. We're working with I cannot pronounce this very well, so I do apologize, with the Kamaluhumaki cultural site that is based in Kona in Hawaii. This cultural site, I have to say, that is very well connected with Cosmovision of the Pacific values and mission. That the picture that you're looking at here, I will say like 5 or 7 years ago, it didn't look like that. It was a hotel and a resort built. And this hotel and resort, it was built in the lands, in ancestral lands for the Hawaiian people from Kona. And this specific location is where the ships from their community used to be trained, and they were later into voyagers to the sea. So this location is very well connected because these people, they found the strength and they fight to get their land back. And they were able to get their land back. They took down the hotel and the resort. And now, in order to honor their history and the place, they built a cultural site and they're opening the doors to host Cosmovision Phase 2. If you want to be part of the Cosmovision Phase 2 and there is any, if you're interested, please, I will encourage you to go to the cosmovisionofthepacific.org website, or you can talk to me and Tim later after the presentation. Thank you.
Thanks, everyone.
Thank you. Unfortunately, we do not have enough time for questions, but Yasmin and Tim will be around, so please ask them questions in person. Could I ask Johanna Casado to come to the stage, please? Great. Johanna is giving a talk based on her PhD thesis. She was the Division C 2023 PhD prize winner. So we're very pleased to have you with us.
Thank you very much. Okay, thank you very much. Hello, how are you? First of all, I want to thanks to the Division C for the prize and this opportunity to be here presenting my thesis. The title is Research on Access, Use, and Effective Exploration of Astronomical Data from Sonification. And my mentor was Beatriz Garcia. Well, our work was centered and continue centered on equity and inclusion on research. We base all of this on functional diversity in a social way, so that we focus on the different sensory style for accessing knowledge. Yes. So in addition, about digital system, we use the user-centered design in human-centered computer interface, and we propose a multimodal display with sonification to astronomical datasets. The goals of the work was the literal review on data sonification, the study of the current regulation, test the tool with individuals with and without disability impairment to investigate usability and accessibility. Update this graphic user interface based on research finding and retrieve data from a specific database for technical testing. We center always, all the time in research. Our theoretical framework and study lead us with the fact that in space science about data accessibility, there is a lack of accessibility on scientific journals and databases, and people comply with what has been decided by the developers. About the sonification data analysis, there are a lot of work done before us, and during the thesis, there are a lot of new tools that I show you next. About the user-centered design, we conduct the evaluation of the evaluation of the software with the people, and we learned that the evaluation of the disability is done in isolation. People think that or center on one disability when the reality is that persons suffer multiple disability in some case. The lack of maintenance of the tools, the lack of including human resource specialists, and the limitation of screen readers. And about sensorial perception, we're based on the Dr. Wanda Diaz-Merced thesis that conclude about signal with a low signal and noise radio, that sonification helps on that. And now there is a lot of work about this topic. Well, about the maintenance, I point here that only 3 of the tools, sonification tools, is maintained nowadays. And now there are new web tools that have the same problem. About our results, it was centered on user testing and about the tool. About user testing, the focus group worked with these 4 categories. The memory overload has to be minimized. The user needs the information about the tools and about the thing that we are doing. They need to choose. Some of the users said that Sono Uno allows them to choose that other software not. There are need of training about the tool and about the technique, and there are different social aspects that has to be taken in account. We work with the email contact tool to reach people around the world. And with that, we conduct a recommendation list and we made improvement by group of functionality of the software. And now, centered on the tool, we have a desktop version, a web version, and we are working also in some script that could be used in Jupyter Notebook. I want to show you here the application of all of this in real data. These are the Pierre Auger Open Data Observatory about cosmic rays. We put the data set download from the page on Sono Uno and made this sonification. About the data of Sloan Digital Sky Server, this is a CSV, so it could be opened in Sono Uno, and now we are working and we present a poster about the use on Jupyter Notebook with the detection of peaks that could be here by sound too. I don't know if you could access to the link tree, but I encourage you to try the QR. And we are working also with a multi-column sonification to be able to discern between 2 different data sets and compare their spectrum. This was a spectrum of a barred spiral galaxy and a double nucleus galaxy, for example. And another application was with the variable stars from the ASAS in database. This is a phase diagram and the sonification used against the multi-column approach to sonify each one of the 2 cameras in green and in black. And all these images was compared with the database, and we are sure that we obtain the same display as in the database. So we are producing the same plot and the sonification is comparable with that. Well, then we work with the invitation of Stavros Kasanevska, I think that I pronounced that right, of the Reinforce project. We work there with the gravitational waves, with glitch particular images from Virgo, with the data of myography, with the cubic kilometer neutrinos telescope. That was image sonification 2, and with the LHC with particles. I also encourage you to hear the sonification about myography and particles. That sonification was done from 0 and correspond with the image again, to be able to make the investigation or discover the particle through the image or through the sonification or both. So here are some of the conclusions. User-centered design for people with and without disability was achieved. We maintain from the beginning the documentation, tutorials, and training that is very important to people to could access the software and the information. The approach has always been a multisensory information display. We are take care always about the combination of or bring the information with the different sensory styles. And all the sonification faithfully represent the data. Now I want to take this minute to tell you about our actual research lines that was done before my thesis. We are working now about perception analysis to understand how people understand sonification and if we could trust on it to analyze data. I'm very sure we could, but we have to test this and could bring to you a statistic that is useful. So in the QR that you scanned recently, there is the access to sono training if you want to test it. We need, and we have a form if you want to subscribe to our email list. Well, and we have here a doctoral student working with this, and in the image, there are two people that are blind, and they are using orchestra. This is from Harvard, if I am not making a mistake, to discover the colors on the image. And there are sight people too. These are from one training course that we conduct at the beginning of the year, and we are planning one other one at the end of this year. Then we are working to update the Sono Uno software with a new framework. A degree thesis was done last year to go to the user, ask for the actual display, and propose this new graphic user interface. We are working on that. Because of that, the interface that you encounter on the QR is a different way, but we hope to the end of the year have this new. And we are working now in haptic devices to be in this tactile mode too. About the sonification with a Jupyter Notebook, there is this poster was for next Thursday, if I'm not making a mistake, and present the use of the things that I show you about galaxy spectrum. And we also work with star classification, with, again, multi-column sonorization. There's a link again. And the last is about the 3D model generation from images. We have a student working on Python code to produce the 3D model print from the image all through Python. This is another poster that will be on the session next Thursday. So now, if you allow to me, I want to close with one, I think I have time, yes. With one phrase that Beatriz Garcia sent to me that said, this work, the inclusion in general, and sonification in particular, is like a brick in a wall that starts in the remote past, with the Celts, Arabs, Chaldeans, Egyptians, Mayas, Incas, and others, and those fantastic women on Harvard. And now we present something new in terms of inclusion of a new technique in astronomy, which is in a testing period, not yet widely accepted, but which perhaps in the future can be understood as a change in a time of great changes. Thank you very much.
We have time for some questions. Yeah, thanks. Yeah, we have time for some questions if anybody has a question. I have a question for you, if that's okay. I really like the ideas of sonification. You've done it from an accessibility and inclusion point of view. Have you ever done any work with artists on using sonification to being more inclusive to other audiences like families and young children?
We have contact with with people on that sense in Argentina about our course the past month. So I think that we are on the way, and we accept all the suggestions. We are very open about that, and we want that sonification was used. So we need all the help us. So I encourage all of you to help us with that.
Thanks.
If we have one moment, I could reproduce a sonification.
Yeah, sure. I mean, you have 1 minute and 38 seconds.
If you want to hear. There is one that was very interested on or anything. I'm trying to find the link. Here. I will show you the spectrum, the galaxy spectrum with marks. That's well, it's just a little part, but the higher pitch are the emission line, and the lower pitch are the absorption. Line. Thank you very much.
And maybe you could share that on the GA Slack inside the Division C channel,
Yeah,
or one of us can do that so that everyone can see, because that was actually a YouTube video. Richard de Kreis also has a certificate to present to you as the PhD prize winner for 2023. So let's congratulate Johanna again. Thank you. And I want to thank all of the speakers today for keeping to such excellent time. There is plenty of time now for coffee and discussions. If you didn't catch up, I'll get you a chance to ask a question to a speaker. We will be back on Monday for another 3 sessions of Division C. Have a good weekend, everybody.
Your default microphone. Oh, that's because you unplugged. Oh, that means I have to mute the sound now.